Good morning, folks. Let's chat. Why does my chat not work? There we go. Cool. So, here's the plan for today. In fact, tweet this real quick. Cool. Welcome, folks. Plan for today, we're going to start off with... Oops. Make this chart. Cool. So let's get started for the day. We're going to do... Let me show where we left off. Okay, so we have our initial implementation of the threaded backend here. Morning, Tim. And we got this to be testable, right? Oops. And lovely. Thank you, Docker. just fix that real quick. All right, the first thing we're going to do today is we're going to try to benchmark the current implementation. We're going to see how fast it is. We're going to make sure we get something that is performant. We'll make sure it's stable, and then we will get to move to TinyGrad. That's the only task for today, is knowing that we have a stable implementation. And then we move on to TinyGrad stuff. Why can't I see your live stream notifications on X? Are you following? It should always show. So it should always show my icon is live. I think it doesn't always notify you when I am live. It's not like YouTube. It usually will tell you in your sidebar, though, if somebody you're following is live. I don't know if it always does. Cool. $10 mil. We're gonna try for 10 mil. Working now. Might just take a second. The one really, really annoying thing about X is it doesn't show you your concurrent view count. So I can never actually tell how many people are watching on X. So I know that yesterday we peaked at 27 across YouTube and Twitch, but I have no idea how many were on X. Wow, cool. That runs. Did that just not train at all? Wait, I swear that I had this training before. This version trained, I'm almost positive, on the other server. Yeah, I must have not. Huh. That's weird. Oh, we'll have to write tests anyways. Let's get a perf check in, though. Yeah, I saw that, dude. I saw that. That's fucked. I mean, to say it's Elon's company is like... I think there are a couple dumbass managers there. Probably the same fuckers that did Yassine originally. Alright, so we have our test here. Let us add a perf check. So let me think the easiest way to do this. Will just be something... this. Let's just go. Perf. Yes. Yeah, should do this. Oh, you need to pass the function handles as well. What if I do this? Perfect. I just needed send and receive, no? I copied the wrong ones. Alright, so where is the C timing? Let's see. Measured in seconds. I don't want the time in seconds. What's the function used for perf checks? I mean, this is stupid. I should know this, right? Do I not have it in here? I do. Wait, am I seriously using time for perf checks? Eh? Oh, because timeout is in seconds anyways. That's not terrible, right? Yeah, that's not terrible. This. I just value, what are you building? I'm working on, first we're doing some perf checks, like some performance tests and profiling on the vectorization backend we did yesterday. And then we're going to do some tinygrad stuff. And if I have time, we'll get to the Ilya podcast. And I have question? Yes, I stream so that people can ask questions and chat. Like, how else would you do it? Wait, how else would you do? Oh, time? Well, you wouldn't use a timing function that's measured in frickin' like integers, right? It's not bad because they're quick functions, and you know, realistically, it's going to be almost just the timeout every time, anyways. All right, there we go. Something basic like this. How many hours do I sleep? Between 8 and 10, depending. Okay, sleep. I slept a lot yesterday. I think I slept 9.5 hours. Now, rest is important. I pretty much usually try to average like at least 8.5. Okay, cool. So we have this perf number, which is crap to start with, but that's a starting point. Now, first of all, I think that we have this in... Yeah, so you see we have this an O0. We will change this to O2. And then this one will also go to O2. We do not have sanitizer of any type on. So first, let's see what this gives us just out of the box. Did I compile correctly? Kind of odd to me that that's such a small difference, but okay. Okay, for now. Now we go to 4096 environments. Oh, wait. I am totally wrong. Hang on. This gets multiplied by num_ems over buffers. Okay. This should be a more reasonable number. Okay, 800K. Now let's go to some real number of environments. The 4096Ms. And there's 20 million SPS. Now, I think we need to make sure that this is actually synchronizing the way we think it is, though. One GPU? Yeah. I mean, we need this number to be in the tens of millions. Ideally, it should be able to be faster than that. There's no reason Vex should be that slow. Like, Vex should be able to be substantially better than tens of millions, but... we basically want it to be no overhead. Since it's async anyways. Yeah, I think that the actual most likely setup that we're going to end up using for this is... Ooh. This is cool. We no longer need to have divisible numbers of threads anymore, right? Wait, should you expect... I'm gonna look something up that's very, very stupid. You can all laugh at me for this. You don't expect... Pure. I actually do not know how this works. Okay, so what the heck is this number? They're the architectural states and some small buffers. Okay, so then you should not see... Cool. That's fine. So then what we want is 6 times 5 threads. 30. But I think you actually can have 5... You actually can have 5 threads. Because I'm doing this for the 6... Wait, 8 times 4. We should have this as 4 by default, yeah. So the default architecture, I'll explain why this is a good idea in a moment. Thanks, fuck, for the worker math was breaking me. Yeah, so, I mean, it's still gonna affect perf, but it'll be easier, Tim. This is why it's dumb, like, why I hate having to, support, like, tons of different backends and things, because it just confuses everybody, because, like, the reason that math is there is for a feature you're not even using. Okay, so this is 18 mil. So this is the most likely configuration that we're going to run. 8192 environments with 2 buffers gives you 4096 environments per buffer. And they no longer get, like, split among threads. The threads are just used to consume work. So 4 threads times 6 GPUs is 24 cores. But then, more importantly, if you have an 8 GPU machine, 8 times 4 is 32. So this fits cleanly. So I actually don't know how many 8 GPU machines only have 32 cores. We will see. This is fine for now. So, let's figure out... Yeah, let's actually figure out what is thinking here. So when you call vec, what is it, vec send, wait, vec receive and vec send, vec workers and cores. Yeah, exactly. Now we have threads, and so the reason that the threads are kind of cooler is because the threads, when I had workers, I had to split up tasks across the workers. But when you have threads, it's more like producer-consumer. So it's just the tasks come in, and then the threads grab them and execute them as they come in. The only reason that we had multiprocessing in Puffer 3 is just that Python doesn't have threading. Pretends to be a real language and doesn't have proper threading. They added it in 3.14, which is still not the main public version. Isn't that kind of crazy, though? How old is Python? Late 1980s. Oh, 1989. Okay, so you have a 35-year-old language. Yeah, 35-year-old language is just now getting fucking threading. It's insane. They needed, well, yes, but like, regardless, the fact of the matter is they didn't have proper threading. And then that language somehow became the most popular language ever. Kind of an important thing to be missing. So what I'm looking for here, I'm looking to make sure that this is not cheating my perf test somehow. Actually, let me just make sure. Put a mem copy async. Wait, I know what we can do for testing. I know how we can test this. I just need memset. Just like a CUDA memset, right? Long on it. It's not that easy, Tim. This is like a new backend. It's no longer general enough. I mean, it's not yet general enough, not no longer. It's not yet general enough. Mem copy to symgoal. The fuck? Mem copy to. Okay, that's my bad for bothering to check the LLM when I can just check the CUDA docs. CUDA memset, and this is not going to be async. Check GPU actions. Start. Val equals. Val. Testing. So the point of this is I just want to make sure that this cannot cache anything. Okay, well, I mean, this doesn't look to me like it can cache anything. I guess we should go just print from the environment, maybe? can do like this. Do 8. Okay, so yeah, here's a bunch of random action garbage getting written. And it's the same random garbage, it looks like, in blocks. So it looks to me like this is getting, the data is getting synced correctly. Obviously, we're going to do more tests than that. That was just like the quick confirmation. Even with 8 M's, you're still getting a few 100K. Yeah, so we have 20 mil step per second vec, it appears. We probably want to figure out... We probably want to figure out bandwidth from that, right? I'm trying to think what the best way is going to be to test this. Like, I suppose, well, it's going to have to be until we get this thing, like, bound generally so we can handle a ton of different M's, I think. And that's when it's going to be that we can test this fully. I would like to see if we're messing anything up, though. Because apparently this doesn't train. That bothers me. Well, obviously we need to do, send this, comment out this test. It was not training before this, which is a problem. Yeah, so that's what I want to do, Carlos. It's just not super straightforward. Okay, that is 5 mil SPS. Which I believe that's about what we expected out of this. That is about the perf boost we were expecting. But that's not helpful if it's completely broken. Let's go get the single thread version of this working, maybe. No, we should just do CUDA stream sync. That's right. End. None of end. Cool. Like this. How did Dan train RL on real Diablo? Presumably he bound it to the Puffer API. I don't know if he's getting any cool results on it yet, though. It's cool that he's gotten it running, but Diablo 1, it seems, is very slow. He said it's like a few hundred steps per second per core. It's actually pretty surprising to me that it is that slow. I would think it would be faster. Like, it had to run on really old hardware, and that's with the graphics and everything. You'd think it would get like a few thousand, right? Like, any of the older games you would think should at least get a few thousand. When optimizing the RL training loop, what metrics are used? Well, I mean, the ultimate metric is throughput, I suppose, for what I'm doing right now. So how many steps per second can we train? Like, we're looking at things in the process of that, right? So I'm looking at, there's overhead from CUDA kernel launches. There is overhead from host device synchronization, which is what I'm working on now. There's overhead from vectorization as well. There's overhead from inefficient kernels. A lot of stuff. Adapted to work. Oh, I see. So it's already okay. Yeah, I see. So presumably there's a bunch of overhead in that repo as well then, Tim. Because Jim is slow as hell. It's already ready otherwise, isn't it? That's already ready. you have any feeling how much faster Puffer can get? Um, it's tough to say because technically you can get like 100 million step per second training in raw flops. In practice, it's very, very hard to even get 10. I'm working on getting 10 for Puffer 4. So Puffer 3 is like 2 to 5 million step per second training most of the time. And the goal for Puffer 4 is 10 mil. So it's going to be like roughly 3x perf improvement on average. That is my target. I mean, you have to think about like, so why am I doing this, right? Because if I were to just say that we're not going to care about models under even 5 million parameters, this gets a lot easier, right? Like, I'm really optimizing this to work with quite small models. There are a few reasons for this. One is that, like, you can actually solve reasonably hard problems without having bigger models. You don't have to go to multi-node or even multi-GPU infrastructure for a lot of problems, which simplifies things. But actually, the thing that I care about the most with all of this is that if I optimize Pufferlib to this extent and still keep it simple, then basically this tech will never be lost behind closed doors at companies. Because like once you can just run something simply on your GPU at home, it starts to become like a hobbyist thing. It starts to like become more broadly distributed. And then, you know, RL is never going to just be this nebulous thing that doesn't make sense that only a few people do. It's really just going to be out in the open. And that's super cool, right? You know, with all the language model things, like you can't really, it's kind of sucks, right? Like with all the big models, you used to be able to do RL, or not RL, you used to be able to do like deep learning at home and actually have stuff competitive with state of the art, and that's just not true anymore in the rest of ML, but it can still be true in RL. That's what we're doing here. Um, Google Colab notebooks are total shit, and the GPUs that they give you on those are so bad you may as well train on CPU. But, you know, if you have any machine with a GPU in it, you're pretty much good. Tech accessible. Well, I am making out, like, that's what I'm doing here, right? I'm doing it here because nobody else is doing it. The truth of the matter is RL is the hardest branch of AI. Like, this stuff is way, like, this stuff day to day, this is way harder than anything you'd be doing on language models, unless you're one of the very few people there who are actually working on, like, their distributed infrastructure and distributed infrastructure and a few of the kernels, I think, are probably the only things that are harder. Like, the actual research work on LLMs is way easier than this shit. And before LLMs got to be the size that they were, like before the distributed infrastructure got to be really crazy, it was just way easier across the board than RL is. Because RL, like, you have to also optimize, it's non-stationary, and you have distributed environments, and then the data collection from those environments has to be fast, and the batch sizes for those data, for the data from those environments is going to be different from the batch size in training, and like there are network differences that you'd want for inference and training. Like there's a whole bunch of other stuff that you just don't even have to think about. Not to mention that, like, until the models get really big, making small models fast is a lot harder than making medium-sized models fast. I've done deep learning without Google Colab. Honestly, Anish, the better thing to do is if you like, you should just set up a local dev environment and just play with shit on CPU, and then when you want to run actual experiments, like... Oh, yeah, there it is, right? They had the pricing right there. 29 cents an hour for a 4090. 36 cents an hour for a 5090. Deving in notebooks is just like, bleh. Interesting. Did I not initialize this? See what I did. What did I do? Ah. This is what I did. There we are. So this should be a single-threaded test. $13 mil. Training on these drones. Alright, so the fact that this is almost the same speed single-threaded means we're either getting GPU bound or the synchronization mechanisms are stupid. One of those two. So I think we need to add a block size. To this. Alright, something like this. Oh. Go over this in block size. Add size. So the idea between this is behind this is just that we're going to do we're going to make the threads fight over the environments less. We're going to give them bigger chunks of work at a time. Start with one though. Five to six. You can do stuff like that. I'll be very surprised if you get anything that, like... If you're doing stuff like that, you should be testing it on harder problems, essentially. So I optimize Puffer to be able to be fast for pretty small networks, because you can solve some fairly complex problems with pretty small networks. But, like, it gets harder and harder to optimize like reasonably good architectures as models get smaller, until they get to a point that they're so small that you just are doing the whole thing in a kernel. But then, like, you kind of cut yourself out of complex problems. Do I believe... I'm trying to think if I believe, like, you could get a humanoid to walk with, like, 1,000 parameters. Maybe, actually. I'd be super surprised if you could get, like, most of the tasks in Puffer, though. Especially the harder ones with nets that size. I think you probably need... I mean, we see improved performance, right? From increasing model sizes. And it's a pretty sharp increase, you know, up to a specific point. Like, we can't get the same perf with too small of models. How come smaller is harder? Because there's essentially, when you have models that are 100 million parameters, there are tons of different types of overhead you don't even have to think about. When the models are 10 million parameters, the overhead matters a little bit more. When the models are 100,000 parameters, there's a ton of different type of overhead you have to care about a lot. Where does that plateau? Go run a sweep, right? Go run a hyperparam sweep on most of the environments with a 32 hidden dimension, and then go do the same thing with 128. Even go ahead and wall clock match them or flop match them if you want. You'll see that they don't match in perf. Like, you just need above a certain number of parameters to learn. I forgot to do this totally, didn't I? Alright, let's do like 8. Alright, this is exactly what we were expecting, right? You see, this is now substantially faster because they're fighting way, way less over chunks of work. So now if I do like 64 or something, 4 maybe. One, and let's see if we go to 256. Just see what the drop off point is. $33 up to double buffering has already been in Puffer. Okay, cool. So you don't really get anything going up to this much. Leave it at 256. This is buffered. This is not the same double buffering. So double buffering usually is like you know, you grab the first chunk of M's and then you do the second chunk of M's where the obs are processing for their first chunk. So what we're doing is we're extending buffering to include the CUDA device transfers. So the obs are going to be ready for you waiting already on GPU, not on CPU. And that's a major, that is a major possible improvement. Actually, we need to now run this with one thread, not 0. So 33 mil. $13 mil. That is not... Can we think about why that doesn't scale perfectly? Let's just set this to one buffer for now. To, like, decomplicate. Uncomplicate. Okay, so we get 10 million with one thread. Take some of the more complex ones in Puffer, man. 2048's been pretty good. We just have. Okay, look at that. So we have 4 threads and we only get 2x perf. That's bad. Oh, wait. Hang on. It's not necessarily bad. Because we can be getting CUDA bound, right? I'm trying to think how we test that. I think we just, like, do like this, maybe? Huh, that's actually slower. Maybe it's... Hang on, maybe we don't have that many cores free. $19 mil. Buffer work with Gen L. I mean, you can definitely try it. Like, the thing that you would want to use is the end vectorization. Like, the most important thing for Gen Algs is the environment vectorization. Honestly, I don't even know if you need GPUs. Like, for naive genetics, you don't even need GPUs. Okay, interesting. So why is this slower with 12 threads? That seems bad, right? $20 mil. Maybe this is the max SPS. I mean, these M's should be basically done instantly. M's 12. Yeah. Oh, you know the other thing that we can do to check this? Still 20 mil. Oh, wait, are we? Is this? Yeah, still 20 mil. So num ems is 16k. Really? 16k ems. $19. Precious views kernels. Yeah, that's the issue. When you're at those speeds, it's like, well, the M's have to be on the GPU. And, like, you can't do the M's on the GPU. You're limiting yourself to stupid tasks. Okay, so it seems like we're capped at 20 million SPS. It's annoying because I can't isolate the environment versus the GPU overhead. I mean, I guess what I can do here, let's do something. If I do 16, 4. What other goals do you have? So it's the new low-level backend hitting 10 million steps per second with the new architecture, and then Constellation. So I guess if you want to lump them together, it's like the high throughput, and then Constellation. So it's going to be a combination of we're going to release the most ludicrously high performance RL toolkit out there, and then we're also going to release the most ludicrously oversized data set of, or like, yeah, I guess data set of completed and tuned hyperparameters, tuned experiments for RL. We're going to have very large scale visualization of RL and then just stupidly fast training. Yeah, you get up to like 30 million with yeah, you get up to like 30 million SPS. What is, so 30 million SPS? But the ob space of breakout, isn't it like, Isn't this 12 gigs per second, actually? Wait. It's 119 floats times 4. Yeah. Oh, that's 14 gigs a second. Is it 32 up, 32 down, or is it 32 total? Ooh, this gets faster as well. That's cool. Fuck. Why did it do this? Oh, there. That's what I want. Good. Okay, so Gen 4. Ah. Huh. Oh, you know, I wonder if this is the thing. I have a theory here. Think with current. I've seen this happen before. Yeah, it's a reporting quirk. Hang on. I'm just checking some speeds here. Hello, welcome. If you got access to a 100K cluster. Harris, I don't even know what I can do with that. Like, on one hand, we're not exactly compute bound with what we're doing now. On the other hand, like, there is fundamentally value to making our stuff faster, right? Like, there is a huge difference in what I'm going to be able to do with Puffer if it runs on 32 GPUs or if it runs on 1 GPU, regardless of whether I have unlimited access to GPUs. Does that make sense? I mean, it's kind of like the difference of like, well, you know, why do you need to have like why do personal computers need to be able to run stuff, right? We can run them on like these mainframes and we have lots of them. And like most of the stuff that I could scale is not currently GPU bound either. It's like CPU bound. Like I would love to just scale the crap out of NetHack and see what happens. I'd love to run full sweeps on Dota, right? To see like, what is like what can we like get full insights on Dota with RL, like stuff like that you could do, but you're infra and CPU bound. You're not GPU bound in either of those. Like realistically, I can absolutely afford to rent the GPU time to do like those types of experiments on Dota, but that's not the bottleneck. I just want to check the bandwidth basically of these machines. I want to see if this is on PCIe 4. Yeah, you see? So this actually is Gen 5. Hmm. So you know what I want to do? I want to rerun this perf check. Backend. This will confirm for us whether. It's going well so far, Peru. I think I got some bugs still, but we're starting to get reasonable speeds. Performance here is 31. So this is not actually faster. Really. Huh. This is up to 14 gigs. That's a little odd to me. I was expecting this to just be double the speed. Well, I think that's fair enough for now. Let's see if we can figure out why this thing stopped training. And then we can move on to tiny grad stuff for the day. If I can at least get this to train correctly. So let me show you Peru, the latest thing. So Peru is the guy who wrote the initial multi-thread backend. I've done a lot of stuff with it since. So here's the latest architecture. You can ignore all these stupid prints and stuff that I was testing things in. So you have your same C thread step from before. You're going to notice there are 3 indices now. So there's the work index, there's the completed index, and then there's the end index. So you wake up the... Yeah, you wake up the worker. And thing I added here, you're going to fetch the work index. You check it versus the end index now, because you get assigned like a specific amount of work to do. You check versus this end index. You're going to do a block of steps, not just one step. This is very important for perf. You basically have everything fighting over the atomics otherwise. And then here, this is adding to completed. So once you've completed these tasks, you mark them as done. This is important because it tells the main thread when all the jobs are done. And then this thing is overflow protection, which this is needed because you can count past the end. And when you are orchestrating tasks the way this is, you need to not count past the end. And then you have this manager thread. This is the new thing. This is not the main thread. This is a new manager thread. Obviously, I'm going to clean up all these names and all this like comments and garbage, and all this spacing. But here, so there are 2 chunks to this. So this is actions ready on GPU, and then the stream is synced, then the actions are ready on the CPU. You check when the actions have been transferred to CPU, and that is when you broadcast to the workers that they have work. And you say that you have a block of new work, block size. And then the other thing that this manager thread does is it checks when completed is greater than block size plus thread plus start index. So what this is this is saying that those workers have finished a block of work. So when the workers have finished a block of work, it's going to initiate an asynchronous mem copy of the observations terminal's rewards back to the GPU. So essentially what I've done to your stuff, so one, I added the double buffering, and that wasn't that bad, but then I made it so that the async also includes the CUDA transfers. So not only are you going to have observations ready for you, you're going to have them ready for you on the GPU, and likewise, when you hit send, you don't have to wait for the action to go to the CPU. That's also done async. So this should basically let you get maximum possible throughput. That is the hope with this. And yeah, we've tested this up to 30 million steps per second VEC, which is 14 gigabytes on the test task. I don't have clean comparisons yet, Peru. I did notice, though, so when I run this, I immediately doubled the speed of training up to like 5 mil from the initial baseline. So I think it's a few million steps per second at least. But I have something broken because it was not breaking training for a while, and then I did something that broke training. Oh yeah, and for whoever said neural MMO for a million years, this is, I think, 40,000 years worth of data that we have from neural MMO right here. So not a million, but we've got 40,000 years. This is actually kind of funny that we're able to get a score of close to 7 with this. This is like a totally garbage network. I have to come up with some more experiments to run on this. Actually, if Kyung swings by, I'm gonna ask him if he can set up, if he wants to test his new sweeps with like 10 billion step runs on Neural MMO. That would be cool. Or 100 billion step runs. Yeah, you probably literally need 100 billion steps to sweep Neural MMO. That's a little tough. Okay. So yeah, Peru, thank you very much for the initial on this, and I'll make sure that this is not a mess by the time I ship it. Honestly, I think all these indents and stuff being weird was just because I was deving on the tiny box, and like Vim didn't have tab expand or something set, and then there's some names that need to be cleaned up. There are a couple other things I was debugging with race conditions, but this whole thing is only going to end up being a couple hundred lines of code, and as you can see, like this is. If we can buffer all that stuff, it'll be nice. Still training after that long? That's the point, though, right? That's why Neural MMO is good. It's because it continues to make progress for that long, right? That's what makes it an interesting environment. Eventually, I think what's going to happen, though, is, like, we're going to come up with something that just solves it and, like, saturates way faster, and then it's going to stop being an interesting environment. It's going to be solved, and we're going to have to make Neural MMO 4. Hey, Autalk. C Rapper Lib Retro. What? Wait. 32 threads. Hold on. Lib. 32 threads. Autark, I want that immediately. Is it open source? Or are you keeping this for yourself? How the hell did you get... Okay, I want to talk immediately. How the hell did you get Pokemon Red to 300k, dude? We timed Lib Retro clone, Lib Z Retro. Wait. How did you get the emulator that fast? We tried like MGBA, we tried PyBoy. Wait. Is it that much faster, or is it the fact that you're not wait, are you rendering? You're getting 300k frames or 300k steps? Comp time everything? Yeah, but like emulators are actually, that is a contested space, dude. That is not somewhere I would expect it to be. No, headless. Okay. Rendering cuts it in half. Only half? Dude. Oh, we don't even need it that big. Huh. "32 threads. Finishing Genesis." Yo, Autark, if this is real, like, you can come help set like one of the best results in the field with this, like really easily. Actually, several of the best results in the field with this, dude. What in the hell? Oh, I will gladly add Zig binds for something like this. Fully GPU resonant. Would that wait? Would that work? GPU resident. Would you like to chat on stream, by the way? I'd be happy to jump in a call with you right now on this stream. If you're open to Discord. Well, like, the main thing that was limiting Pokemon Red. So why was Pokemon Red such a hard project? Like, yes, it's a hard environment. Have the wife and son hang out? Okay, that's totally fine, dude. I understand. But, like, holy crap. But I wouldn't expect this to be possible because... So the logic here is that emulators are a pretty contested space, right? It's like, there are, like, several emulator projects, and speed is pretty contested. Only 3,500 lines. Holy shit. And Wasm. Oh, of course, Wasm. But that's... Oh, that's so good. 5x speed up in training. How the hell? Is it... Wait, so is it 100 and 125 with rendering? It doesn't have to render for reference. Like, we can still make use of this, I think, regardless. Also, how on earth would this work on GPU? Like, would it not be slower? I mean, Pokemon is about as branchy as it gets, right? No, I added audio and rendering because I'm a nerd. Well, I mean, training on frames is not terrible. Like, it's all pure Zig comp time. What do you mean it's all pure Zig comp time? What is done compile time that was not done before at compile time? All the branching? Just one big unrolled... Wait, what? Is that not, like, massive? Wait, how? One... Jeez. I'll start reading some Zig code for that. Where's big file? Oh, where's big file? Oh, these are small files. Where's big file? Awesome. Awesome. Batch. GB. Oh yeah, so this, by the way, this is when I say that we're doing, like, stupid baby engineering in Puffer and it's still fast. This is what I mean. Like, we're not doing any SIMD and Puffer is still as fast as it is. That's what you can do actually fast. Okay. Okay, so how is this entire thing unrolled compile time? That looks like an emulator. $140 final jump table. Yeah, but 140 mil SPS on cart pull is nowhere near as impressive as this. Like we get, I think we get, what is it, like 60 or 80 mil, something like that? Instead of function pointers and trash. The final jump table is just a switch. Huh? Yes, Autark, but like, for context, I can't even tell you how many people will like show me some I made very simple thing fast in a way that like clearly is not going to work on anything else, right? So there's a huge distinction in my mind between like I made simple thing fast and I made thing fast in a way that actually is going to work for problems we care about. So most researchers, they basically go, oh, we can't make anything that we care about fast. We're going to just have everything be slow. A lot of perf engineers that don't understand RL will like make stuff fast in a way that doesn't actually help. But then getting both of those at the same time is very rare. Hit a wall with libretro. I will 100% spot compute for this, dude. Like, I think 32 cores, we should be able to get it training at near that speed. Why is a Zig Game Boy emulator so important? Because if we are able to run like any Game Boy game on this at over 100,000 steps per second, then we can use them for research. The problem is if the existing runs run at like a few thousand steps per second, which is too slow for research. So this basically makes all of our compute worth an order of magnitude more. It's been less than 24 hours of day. What? 24 hours of dev? How the hell did you write 3,500 lines of code in 24 hours? And Claude. Bar to const. Oh, it's just these summaries. Well, it's the summaries. Do you believe I wrote zero code by hand? If you wrote zero code by hand and this is correct, then I will be incredibly impressed. If you wrote zero code by hand and this ends up being completely stupid, then that will be another story. from the web folder. Hang on, let me think. Wait, this is like... Yeah, see, I don't know enough about CPU or, not even CPU, like old architectures. Yes. I mean, I want to see at least a couple training runs out of this, or at least a binding so we can play with it first. I mean, I'm a little suspicious by the fact that you gave it targets that are obviously impossible. They aren't impossible. I'm pretty sure there aren't enough flops in the CPU for this. Okay, you wrote frames. You hit 5 mil single thread? Let me think, would I believe that? Through an emulator? I don't know if I would believe that through an emulator. You write a 1500 line emulator that hits 5 mil. I don't know if I would believe that's possible. I'd be pretty damn surprised if that's actually even physically possible. Genesis? The hell is Genesis? ArrayLib native binary. Isn't this the same guy who did Pokemon with Q learning? That's Peter Whitten. Liberty. Oh no, that's not Q learning. He was using PPO. Like the main Pokemon Red project is Peter Whitten. Oh, Sega Genesis. If you get one game in here, like actually training at 100K, or from this, like it looks like 200K. Wait, there's no way that it only gets cut in half as well with rendering, right? No way. I guess we do like 24 frame skip in Pokemon. With that, maybe? Not as optimized as... 9. Well, you can't frame skip the state updates. The only thing you can do is if you wanted to train on pixels, you would do like 24 frame skip for Pokemon at least. So 20 every 24th state you render. I mean, Autark, you should literally be able to hook this up to the Pokemon Red repo, right? Could you just swap? Can you just swap this with the, like, as the backend with Pieboy? Wait, you get 22K per thread, and then the threading is just bad. What? Wait, AMD Ryzen 9. What do you have with the AMD Ryzen 9 that even has 32 cores? Oh, 32 threads. Wait, what? AMD? Which one? I don't. The fucking AI keeps changing that. Oh, what? What CPU is this tested on? Wait, i9 13980H. What is this? Oh, this is a shitty CPU as well. Huh. So you tested on this and you got 11x speed up. I think 16x is about what you expect out of this CPU with good threading. So actually, this would be way faster on one of our CPUs. Freaking laptop, okay. So yeah, this would be like 500K plus. Okay, well, all right, look. As always, I am incredibly suspicious of AI workflows in general. I have literally never seen this work, but this does seem good, and I've seen you do other stuff. If you get anything remotely in this ballpark, like hooked up to Puffer and training, this would be like a massive, massive thing for AI, because we would be able to have access to real, like, tens of hour long games training at hundreds of thousands of steps per second, which is like one gen behind our fast M's, but like that's still really, really solid, and we can use those for a ton of research. Um, yeah. I will be sending a lot of things your way if this is actually correct, and I will probably have to go reevaluate a bunch of stuff about LLMs. Like, Autark, if you get us a demo of, like, here's Pokemon Red training at 100,000 plus SPS, like, yeah. Not a vibe coder? Dude, if you said you wrote literally zero code, are we using, like, are we in the same reality here? Because like, I've tested all the models at least at some point, and they are all eating glue. Like, I can never even get models to output a 30-line chunk of code that is not dog shit for anything remotely sophisticated, ever. It's literally a meme in here. So I think I will reserve judgment until we see that demo. And the same goes for you, FBR. Like, I will believe, because I know you use LLMs a lot. Like, I'll believe it when I get an actually really impressive PR out of it for a thing that fully works. Particularly if you're getting anything remotely compact out of it. Wait. Okay, yeah, you do have this. Compiler's not going to let you make any mistake. You can absolutely have bugs in frickin' Zig. Not be possible. Liberty, I don't do 80% of the code with LLMs, though. Unless you're considering, like, the one-line autocomplete I have, that is such a stupid model that's basically just an LSP at that point. It's like a slightly better LSP. And, like, I intentionally have that stupid model as well. Well, whew, okay. Yeah, Autark, yeah, let's get a PR on this. If you actually end up getting, like, the Pokemon demo running at 100K and we can train the model on that, that will change a lot of stuff with Puffer. And we will have to talk about professional stuff as well, because I will have some offers for you. But I'm going to want to see it first. Because I don't know how the hell... I don't know how the hell you got this out of Claude at all. I'm running Zig on the CPU. What do you mean you're running Zig on the CPU? With 80% of the standard library. Wait, what do you mean by that? Zig compiled to CUDA. Wait. Compiled to CUDA PTX and running. Did you mean to say running it on the GPU? I still don't understand how this thing is one giant table. How big is that table? How big is the switch table for this thing? What the hell does that even make sense? There's no way, right? JSON decode. Well, but like Autark, so the question I have is like, how fast can you get this entire thing on... I would think that this thing would just be slow on GPU because of branching. Like the architecture I'm working on now is for CPU vectorization with buffered transfers to and from CUDA. So we're exploiting the fact that there's going to be some model inference time, and we're going to buffer the transfers while you're doing model inference for the next batch. So the idea there is that we should be able to get, first of all, pretty close to PCIe speeds with decent batches, and then that time actually is going to get amortized by the inference time anyways. Yeah, but we're interleaving more than we're interleaving even in Puffer 3, right? Because in Puffer 3, we were interleaving the CPU time, but now in Puffer 4, we're also interleaving the host device and device host transfer for OBS and actions. So it's mostly for OBS. My understanding was that, like, you shouldn't be able to get arbitrary stuff like this to just run fast. CUDA graphs and streams. No CUDA graphs yet. That is to be determined. I actually want to mess around with TinyGrad a little bit first, because they have some interesting stuff for overhead. Streams, yeah, each buffer has its own stream. But that's not for the network. That's for OBS and action transfers. Yeah, I think I'm going to have to, like, jeez. If this thing frickin' works, man. I'm trying to think how the fuck this could be. Literally, how the hell could that be faster? Like, just writing in Zig is not enough. Yeah, but like... CB opcodes. This is not a giant switch. This is a fairly small switch. No function pointer bullshit. This is function pointer bullshit, isn't it? Oh, I guess the compiler is gonna unroll it, yeah. No way saving one function call, though. What was the... What was the frickin', Oh, did it not have... What was the frame... Wait, 37395. You're saying 10x faster? 395. Yeah, 10x. Wait, no. This is 32 threads. One thread. 22k. So wait, then this would only be 3x. Wait, that's even... Wait, that's the same speed. That's literally the same speed. But wait, is this single core perf? It is, isn't it? Oh. I see. I didn't account for the frame skip in that. Skip 15. Divide by 24, and you only get 10K. Ah. That's the kicker. Well, you wrote the spec to 5 million, so point stands. If you get 100K training, I'll be very impressed. But I'm pretty sure when you actually, wait, when you equate these numbers, these are the same numbers. It's the fact that training, this ends up getting cut by like 24 by frame skip. Hmm. Okay. I'm more convinced that this is possible now. But it's possible because actually I think this is the same perf. Highboy state format. No. We will see if you can get this to be faster. You don't have to match exactly, but I think the easiest thing to do would be to like just show that you can train the Pokemon network faster. Admittedly, that's a giant code base at this point. But I'm pretty sure that when you equate those, they actually, the perf numbers match between these two. Because it's 1K per core. Yeah. Okay. Well, if you do manage to get this to be way faster to that 5 million FPS, which then goes down to 200K with reasonable frame skip, or even if you get like 2.5 mil, if you get 100K training with the frame skip already applied, then you have something crazy. I will be very, very surprised though. But at the current number actually does match roughly what you would expect. Okay. I gotta get back to this vectorization, and I will see what you cook up throughout the rest of the day. Let me go get a refill on my coffee. I will be right back. salvageable from... Wait, hang on. What are all these questions? Hi, I'm doing research on multi-objective RL a couple months ago. Discord about multi-objective RL and Puffer. Wrapping mode gymnasium environments and Puffer managed to do pretty easily. Puffer doesn't really work with multiple rewards. Yes, it doesn't work out of the box with multiple rewards. You can tune any combination of them that you would like. Works by training a policy that takes as input the observation plus a weight vector to scalarize the reward. You would just cheat the weight vector into the observation. Wait, scalarize the reward. Observation plus a weight vector to scalarize the reward. Takes as input to scalarize the reward. Oh, Paul, all you would do, that's actually super easy. You can use all of Pufferlib just fine. Literally all you have to do is take your multi-objective reward, like your multi-component reward, and cheat it into the observation space. You have your obs. Let's say a reward has 5 components. Last five spots of the obs are going to be, last 5 entries are going to be the reward. And then you just, when you're training, you just split out the observations. Just hack the pufferl.py file to split out those obs and then use it for your algorithm. Done. Easy. And if it's purely inside of the network, then it's even easier. Oh, it is cold in here. Let me get myself wrapped up. It is absolutely freezing in here. And unfortunately, that's how I need it to be so I can think straight. Yeah. Autark, if you're still here, I will be monitoring progress on this. There will be a huge difference in whether the project ends up being a port of Highboy to Zig that is roughly the same speed, or if it ends up being like architecturally different and way faster. If you get something that is architecturally way different and faster, and you've been writing all your code with Claude, I will be completely and utterly shocked. Is this H open RSC? Oh wait, this is the RuneScape dude. Yo. Are you in dev? Where did you do? Wait, where's the herd? Wait, this is not you as well, right? Where is the... Where's the post in Discord, Autark? I'm Autark everywhere. Okay, this is somebody else. Then where were you posting stuff? So if I want to adjust weights during the training process, I should control that from the end. No, you can keep the weights as part of the network, man. There's no problem. You just have to cheat the... Like, you can do that wherever you want. The only thing you need to do is expose the rewards to the obs and then just split them off. And then, like, that's how you... basically anything that you want to communicate from the environment to the main process, just stick it into the observations. Instead of trying to hack Puffer to add an additional communication channel, just stick it in the observations. Hey, Jess. Didn't post? Oh, okay. I thought you said that you posted something. Okay. That was a bit of a detour. Ugh. It's still cool, though, to see, like, a new emulator in Zig in 24 hours is pretty wild. But that is something like, okay, I will believe that an experienced dev who has actually written a bunch of code by hand and is now, like, just doing stuff with, like, I would believe that. If you hit 5 mil, or even, like, if you hit 2 mil SPS, I will be shocked, and that will be a whole nother story. The thing that I'd forgotten is I'd forgot to account for frame skip, right? So 200K, 240K, then 24 frame skip. You know, you're down to 10K, which is roughly what you can get with PieBoy. FinTech CTO. It's cool that you do this number of projects then, when you have other stuff to do. I mean, this is my full time, right? I do some client work as well that I don't stream around Puffer. But I spend pretty much as much of my time as I possibly can on Puffer itself. Recovering from a dislocated knee? That sucks. I'm sorry to hear that. That actually sucks. As I've gotten more and more in shape, I value my ability to train so highly that, like, I basically don't do anything where I could possibly get hurt anymore. Because I go batshit insane if I can't train. Yesterday was intended to be a 1 mile PR, but I think I tied. I think I tied it. Okay, back to this. We were testing end bindings. Created all my life from a computer. And home to roost. Well, that's how tech goes. I've traded very, very many things to be able to put in the amount of time I have with this, and I mean, it's ultimately so cool, though, that I can now, like, shape a whole area of science. Stuff I do. I will say, Autark, I was out of shape. I think I started, like, really trying to train seriously again 4 or 5 years ago only. I think 5 years ago. And I didn't start running until, I think, 3 years ago. Been the best thing I've done, though, by far. Puffer Strava when? I haven't synced it in a while, Finn, because I got a new phone and I have to, like, actually set it up on that. I have all the data on my watch. I'll check all the PRs at some point. I set a bunch of them. Jess, the creatine experiment was a complete and utter failure. No, that does not work for me at all. It just kills my stomach, any form of it. We will try again once I have made other adjustments. Okay. This test is going to be 1 buffer, 256 block size, 0 threads. Wait, is this puffer on the right one here? Yes. Yes, I'm on the right one. Thanks for the pointers and insights. I'll explore direction if having rewards, vector part of obs. I think that's going to be the easiest thing for you, because then you can just slice the obs, right? And you can do whatever you want from there. Moral algorithm uses Pareto dominance to keep track of the set of weights that results in Pareto optimal. Keep track of the set of weights. Well, if you think of it as just Pufferlib as the whole algorithm in one file, like, so if you have to add a thing that doesn't archive over the policy, then you're going to have to add some additional logic over it, right, throughout training. Kind of the same way that the sweeps does. But like Pufferlib, if you look at that file, it's maybe 400 lines of actual training logic, and then a whole bunch of performance benchmarking and logging and stuff. So like, if you think of only having 400 lines of algorithm to hack, the only thing simpler than Puffer to hack is CleanRL, and CleanRL is slow, right? Like Puffer was meant to be fast CleanRL while keeping as much of the simplicity as possible. Threads, buffers, block size. You have a degree in what? Bachelor's in CS from Stanford, PhD in EECS from MIT, if you care about the formals. I mean, I've pretty much just been doing AI the whole time for both of them, though. Like, the degrees aren't actually as specific as the thing that you're doing. Oh. Create M's. Yeah, I messed this up. Right, so this is supposed to be M's threads. Bro. Yeah. I mean, I try not to flex the credentials, except when you have somebody that, like, only cares about the classic credentials. Which unfortunately does happen occasionally. But... Zig is so hardware optimized. Would Puffer work better if you were written in Zig? See, that question... Okay, that's a dumb question. Let me explain why that's a dumb question. Zig is not faster than C. Alright? Zig is not faster than C. What does it mean for our language to be hardware optimized? Like, you can say that about, I guess, Python versus something lower level, because Python doesn't compile to either... It doesn't compile to machine code, directly. It goes through an interpreter. Like, okay, but basically anything like Rust, Zig, C++, C, they can all be the same speed. And all the environments in Puffer are written in C. The training is PyTorch. And yes, there's some Python overhead, which is what I'm dealing with Puffer 4. And there is like language overhead, but there are many other sources of overhead that are completely independent of the language as well. Zig is faster than C in most situations. The current benchmark that you have is currently equal to PyBoy, which is Python. Did you see this? So far, if you're going to make that claim, where is it? I've not seen any benchmarks that give, like, your compiler would have to be better. But don't Rust people say the same and they're always wrong? Where was the link to your thing? Zig. It's not going to be indexed yet, right? Oh, actually, there are a couple of these. But probably nowhere near as good. Rust people do, and they are. Yeah, Rust is usually slower, right? Because, like, the way that you make Rust fast is you either write unsafe Rust or you be very, very careful. Zig, I will believe, gets you, like, C speed most of the time. Yeah. I don't see what the hell Zig, like, okay, if your Zig is faster than C, what is it what is it doing that C is not doing? Like, you wrote your own SIMD. I don't think you write your same, like, basic normal code and see outputs faster. Compile time versus runtime. What does that mean? Like, what can the Zig compiler optimize that the C compiler can't? Right? As far as I'm aware, Zig doesn't change your programming model fundamentally. But I don't see what other optimizations the compiler would be able to introduce that your C compiler can't. You wouldn't be writing normal C code. Okay, but like, your normal Zig code looks pretty similar to your normal C code, doesn't it? We're talking nanoseconds. Well, if you're saying it's faster, like, being faster would mean that there's an appreciable difference if you just, like, write the same program the way that you normally would in either language. See with LLVM annotations. Where do the annotations come in? I didn't see anything in the source that, like, looked all that fundamentally different. Like, honestly, Zig looks like, to me, it looks just like what C++ should have been. I'll give it that. I will admit I don't know about like what safety stuff the Zig compiler enforces. I know it's nowhere near as heavy as Rust. Don't really use LLMs to help you. Yeah, that is the usual discussion. I do not find them helpful. Other than mostly for fuzzy docs and fuzzy LSP. I don't find them helpful for thinking, let's say. I was working on this thing, and then I got like completely distracted by the emulator, which is a cool project. I will wait on I mean, hey, ultimately, if he makes it substantially faster than PyBoy, I will be very impressed. TypeScript is Java with type annotations. Is TypeScript faster, or isn't it literally slower? I thought TypeScript is literally slower. Like Python's types, if you enforce Python's types, it literally makes the language slower, which is a joke, right? This instaseg faults. Did I screw up? Create M's. Threads buffers. Buffers block size. Buffer. Yeah, this is correct. And not build. Wait. Oh, that's actually fine. Buffers. I forgot one thing. Yeah. This should be 2. What's the possibilities with Zig? So, Kinvert, it's still a awesome project, but the thing that I had not been factoring in was the frame skip. So far the reported single thread perf number from Autark matches PyBoy's single thread number. So I'm waiting to see if he gets it to be way faster. I've dropped it in PocoGem. Oh, okay. Let me think. How do we... Invert has run it himself. I can get a box for that. Invert, you got a spare box for this? We can do, we could run this on that. Okay. Dropped it into PocoGem on GitHub. Yeah, get it synced up, and like Kinvert, if you want, like, I'd like to see a run of Pokemon with it. So that'll be the correctness check, and then Autark, it'll be up to you to see if you can get the perf numbers, because like, yeah, the problem is if you don't include frame skip in the perf numbers, right? Like, you're almost never going to train 60 FPS. Like, unless you're doing precise control. But like Pokemon, you press a button and like the most amount of time, the minimum increment of time that matters in that game is like, I don't know, 20, 30 frames. Did you get him that paperwork thing yet? No, I got just the paperwork thing for chess. Don't have frame skipping at all. I assumed headless. Well, frame skipping is just like, you have a render function, right? So it's literally you just call render every 24 frames if you wanted to do that. Okay, is something massively broken here? I believe there is, right? Yeah, there's something massively broken. M's, because this is 0. Yeah, 0 threads. Okay, then I did fundamentally break something, right? What are you using to live stream this? Restream. Of ALU and CPU. Yeah, once it gets like on the public GitHub and we can look at stuff, Convert, I'll get him on it if he's gonna do stuff around here. Hmm. Like this sounds like it's more of like a hobby like slash cool thing, right? Like if you're if you are a fintech CTO, you're not going to be interested in like professional stuff, I'd assume. Hmm. Consulting if the price is right. The price is typically 50% of whatever we're charging clients, as we do. It's like contracted work with for companies building custom sims and stuff. Yeah. So with how I'm running Puffer at the moment, it's just dramatically easier to do everything via contracting like that. Because it lets me just give people a good percentage of whatever we're making without having to like set aside more for for risk and stuff like that. Compile TypeScript to get optimized JavaScript. I that seems possible, Son of Liberty. Is that actually what happens? Because in Python, when you add types, you actually make it slower if you enforce them. I don't actually know if JavaScript gets faster with types or not. Like with Python, if you write Python instead, right, then it gets faster because it compiles it down to C using the types. But if you just use the naive type system and then you use something to enforce them, you don't get any perf benefits and you have the overhead of enforcing them. But like the thing is, both C and Zig are typed already, so I don't know what additional annotations you'd be writing in your code or that the language would be enforcing to let you get any optimizations, right? That was the point from before. You annotate compiler hints. I'd have to see some example of that. Like, I don't... Like, you can technically do that as well, right? There's, like, unroll and stuff, sure. At splat. Oh, okay, I see. I see. Do you not have, like, pragma unroll and stuff? That's an area I really don't know very much about in C, because we never have to optimize to that extent, right? We just write like brain dead simple C with without doing dynamic memory allocations everywhere. and you are already fast enough in almost all cases before you even have to do anything else. You can just use inline. Yeah, we inline, we inline some small function, sure. Line does. Yeah. I mean, there are obviously way more things you could annotate. So yeah, I could see that. But that doesn't seem to me like, oh, the language is faster, right? That seems like if you are using specific annotations because you have low-level knowledge of what the compiler should be doing. Like in the same vein as unrolling loops and stuff, right? Annotations are part of the language. Like pragma, unroll. Where's that? Oh, that's CUDA. Does C not have macros for this? I've literally never had to do this. If it doesn't, that does seem like a good thing to have. Aren't the C language? File time is literally code. Running. Use it to generate more. Literally C code running at build. Use it to generate more zig. Macros aren't the C. Macros aren't the C. I agree that the macro, the way macros work is kind of jank. Yeah, I mean, it seems like Zig has some nice things. I've already said, right? Like, it seems like way, way better than C++. Like what C++ could have been, for sure. Over to compile time. Yeah, I mean, there are places where you want perf optimizations, and there are places where it doesn't matter, right? Your innermost loop of whatever it is you're running a billion times, you want to be very well optimized. I'll get to that level of optimization, I'm sure, like relatively soon in sim development. And I'll see how it feels in C versus in other places. Oh, how are Zig's build times, Autark? That is one of my favorite things about C, is just everything builds instantly. Python gonna be the bottleneck. Convert, we're already doing a non-Python backend. And like realistically, I honestly am expecting I think that the Python version of Puffer 4 is going to be like pretty close in speed to the C++ version, believe it or not. Because like the operations that have a lot of overhead are all going to be fused into single kernels or whatever. About the same. That's cool. I don't know. I could jam, like, I think I probably would not hate Zig. Like, obviously, I've chosen C for Puffer because I really don't think Z has the same level of adoption. If Z were a super popular language and not just, like, currently the trendy hobby language, I'd consider it. But as for just, like, picking the stable, universal thing that is good, C is kind of the obvious choice. picked up quicker than Rust. Well, I'd hope so for that. Rust is just like, this one does not bring joy. I hate pretty much everything about that stupid language. It's still better than, I think it's still better than like modern C++, but that's a low bar. No borrow checker or lifetimes. Same pattern as freeing. Yeah, see, I don't know why that's built into the language either, like autark. You should just be able to, like, an allocator, an area allocator takes like 20 lines to write. Like, it's not a bad pattern, but I don't know why it's like such a big selling point. Like, this kind of like reminds me of the people who find it amazing that you can write a, you know, the T.S. Odin clip where he like writes a list or a vector in C and everybody's like, oh, you can write lists in C? It's like, yeah, how the hell do you think they're implemented? Modern C++, no good. Rust, better. They both suck. Allocator that works on GPU and CUDA. Oh, actually, I do have one question for you, Autark. So the one negative that I noticed with doing area allocator style things is you break address sanitizer, right? So if you have like each thing has its own allocation, then when you write past the boundary of that, you can catch that with the address sanitizer. Whereas if you bunch all of your allocations together and you write across the boundary of one thing into the next thing, but not out of the entire block of memory, then you break the sanitizer. Or is that handled for you? Nah, C++ sucks. I have no... The only good thing about C++ is that you can technically just write C in it. Use the testing allocator. It's default and debug. That's not terrible. I think it's better to just have the compiler be the thing that you change to test your code rather than your code itself. But it's not bad. But how does that thing work, though? I guess it marks the boundaries every time you request a piece from it. Yeah, I could see that working. That's actually, yeah, that's a good thing to have built into the language. Because then you get area-style allocations, but you don't break your sanitizer. Yeah, I could see that. That's fine. It's slow as fuck. Of course it's slow, right? The same thing, I'd actually be interested to see how slow it is compared to, like, C's address sanitizer, right? Or, I guess not C's, but, like, Clang's, right? Because, yeah, your code gets super slow, but it builds fast, and it's still plenty fast for testing stuff. Yeah, I've been yapping enough here. It's been good chatting, but I need to actually get this stuff done because I want to get to Tinygrad today, guys. I want to also have time to do Tinygrad stuff today. And we just have to fix this env. Gives you more confidence that compiles and test pass, it'll run. Compiles and test pass. Yeah, I don't know. I don't mind the, you know, the runtime sanitizer checks debugging. 0.979x of Pyboy. I will let you work on that for a bit. You said 5 mil. I'm not going to hold you to 5 mil. If you can get 2 mil, I think that's already... I think 2.4 mil would get you 100k SPS with frame skip. Everything is still Python resident. You do not need to make it... It can be batched 100k if that makes sense. So like, yeah, it's the batched one that has to be. So if you're running like the loop in Python over each end, it can be batched in groups of, I don't know, whatever they used for training. So it's the vector step, autark. That'll take a lot of the overhead. Like obviously if you're stepping each end within a Python loop. So you'll stream on Monday, guys. It would be today if I could shut up and like get this stuff done. But I mean there were some cool things to look at, so not so bad. Render downsamples. You could have your rendered, you could have the downsampling built into the emulator. That would be fine. In fact, that would be better. I actually would believe that you could probably shave a lot of time off of the rendering with fused downsample. Like, that is something that I would believe that there's a legitimate optimization in. You don't output pixels every step. You'd output pixels like every 24th or whatever. Pokegym, you do not do pixels every frame. That's not how the current implementation works. If that is how it works, then they're dumb. Like, I do not believe they were that dumb when they implemented it, though. It only renders every 24th. I break here, man. Oh, nothing. Dummy. Okay, so here we have this. You're not gonna beat it by much doing that, though. Most of the runtime is not the rendering, it's the states. Because you're only rendering every 24th anyways. You'll be able to make the render step way faster than PyBoy. I believe that. NumPy bullshit. Yeah, that's not the emulator though, right? That's like that guy's code. The base emulator is still nowhere near speed. Base emulator is only like 1K per core. So upper bound would be like 16K. Probably. That's still 2x faster than their current code, but then there are other sources of overhead with it as well. Actually, the thing that I'm doing right now will be a nice little boost. Because it'll eliminate some of the copy overhead. This is not for Pokemon specifically. This will just be general purpose improvement. What the heck did I screw up here? Extend. Stream synchronize. Vex streams of buffer. Right. Then C step on end. Oh, I didn't transfer the obs, dummy. Yeah, I didn't transfer the obs. Try this. I hate that I'm pasting this everywhere, but for now we will try this. Okay, the second I actually pay attention. So this is this still bad? This is substantial training, but this is significant, but this is still bad. Do something else weird. Honestly, that seems fine to me. Act size. One. Ob size is 118 on breakout. Yeah, 118, not 119. Correct. Let me see what I did with this loop. I might have messed something up here, honestly. I kind of did this super quick when I was tired. So, what did I do here? Num buffers times horizon. I have index percent buffers. I divided by num buffers. Messaging me. State batch. Narrow should never... This should always return a view. This should always return a view, yeah. So obs buffer. Copy in obs batch. Copies in action batch. Copies logs. Values. Rewards terminals. Actions. What about actions? Actions is float. Huh. So 256. This is non-threaded though. What could I have possibly messed up without even having threading? Well, this is the jank one, right? But this is not supposed to be... this is not supposed to break everything completely. Warp. Hmm? So anything above 8 is substantial training for breakout. But yeah, it's like way worse than before. Yeah, see, we have hard-coded 8192 M's. Zero threads. Check send with the buffer. I%. Yeah, so this is... Oh wait, did we take a speed hit without me noticing? No, the speed hit is from being single thread. Okay, that doesn't help. Actions equals Pufferlib env actions. Ooh. Env obs. Wait. Spec obs actions rewards terminals is create environments. Create environments. Create. Okay, so obs actions reward terminals. These are all the GPU values, right? So then this vec gets that. Pokegym is the overhead, not the emulator. So that thing does Pokegym is mostly an env wrapper that does a lot of state manipulation to produce custom obs. Yeah, that thing is going to have a bunch of overhead, but if you're at the 20 whatever thousand it was single thread, then you're still roughly matching the PyBoy SPS. And if you assume you can get a 16x speed up, the fastest you could possibly get would be about 16k training, which is better than what they peak at like 10k, but it's not like a generational difference. Yes, and we have to convert between. Yeah. We have to convert. But I think that the base emulation speed, like, it's still not like it's 10x faster on the base emulation speed, right? To give it the exact same. So ultimately, you don't have to do that, right? I thought that that would be a convenient test. But, like, you can obviously merge, like, as long as you have an OBS format at the end of the day, right? The puffer end format is useful because you can't get as fast without the puffer end format, because that's literally just a vector format that saves you a copy. I guess you can just pay the copy overhead, I guess. You're going to have a worse RL algorithm, though, if you use custom framework. Unless you've re-implemented the puffer train algorithm. You are free to find that out the hard way. But the RL algorithm is not something that you can simply just, like, do a custom one and have it be as good. Yeah, so you'd have to port it. Evolutionary PPO. Evolutionary comma. Yeah. So there is a generational gap between PPO and what we have. And Evo is like, yeah, that does not work. I mean, as you can see, this is the stuff that I'm working on at the moment. You're closer to CleanRL? I mean, the style of the code we get as close as possible, but, like, CleanRL, we're trying to get, well, no, because CleanRL doesn't have any of the, like, the algorithm that we have, right? Our algorithm is a bunch of modifications on top of PPO that we've tested on all of our M's. You know, we've made improvements over the course of time. You also need the vectorization method. You'd need this exact thing that I'm working on now, this double buffered vec. You really can't make stuff fast without that if you're going to have CPU environments. The new thing I'm working on here will also cut out the transfer overhead. As you can see, it's a fair bit of work. Oh yeah, that guy. Was there substantial CUDA device overhead with the Pokemon experiments? Because the thing I'm working on now should more or less eliminate that type of overhead. Cut it down significantly, yeah. So what I'm doing now is, instead of just buffering the end computations, like double buffering that, I'm also buffering the CUDA transfers. So you'll get OBS not on CPU ready, but you're going to get OBS on GPU ready. Yeah, emulation is still the biggest bottleneck. That's for Pokemon specifically. That would have to go up an order of magnitude, I think, to make that env, like, I'd say even usable for modern algorithms. Direct to device, yeah. I'm working on some pretty cool tech. It's going to be like a couple million SPS boost at least as well to the C backend, because the C backend has lower overhead like the C++ backend has lower overhead everywhere. So really, this is the main source of overhead. And then there's, like, CUDA launch stuff and other things, but this is the main one. Oh wait, is this KUint8? Did I mess this up? I think I might have messed this up, right? Wait, KUint8. Hang on. I don't see anything wrong here. Does copy underscore, is this safe if I do? Term buffer, if this is a K float, is this safe? Actually don't know. Write into compiled languages as needed, not just cuz. Yeah. Well, honestly, we're going to have both. So the idea is going to be that it is substantially easier for me to do the development here, in fact, because I know there is no Python overhead. And then the idea is that I'm going to have chunks of this exported as standalone functions to Python. So I think that the Python, ultimately the Python version is going to get pretty close to the C++ version, but it's still going to be good to have this regardless, because like I wouldn't be able to dev the whole thing in Python. Hard for me to follow what you're doing. Follow bits of it. You can ask questions as well. At the moment, I'm trying to figure out what I screwed up while I was developing. I broke the vectorization backend here. Context thing above. Was this literally it? Wait, seriously? That still seems broken. Still seems broken. Moving between Python and C. For specific blocks. No, you're strictly removing overhead in this case. There are ways you can do it where you would incur overhead. The way I'm doing it, like, no. Because basically every call, like every single line from Python has the C to Python overhead anyways. You're strictly removing overhead by batching them. Software engineering design, getting more ML. What are you optimizing right now? So what I'm optimizing now is we have a whole bunch of environments, so a whole bunch of instances of the thing that we're training RL on. And I am writing a backend that multi-threads the execution of several thousand instances of environments. And I'm doing it in a way such that you can run them asynchronously, so that by the time you need data from one set of environments, it is already ready for you. And the thing I'm doing at the moment is in this new backend, it's going to be ready for you on the GPU. So it's a whole bunch of like asynchronous data transfer stuff. How did you learn CUDA? I didn't. I just started writing it. I wrote a bunch of C and then just went, CUDA's just C that runs on your GPU. How hard could it be? And for stuff that has like pretty trivial parallelism, that is kind of just true. You can kind of just like pretend you're writing C and it's the same thing. They're floats. I gotta go look at what I had this as before, man. I think I messed something up. Go down to, like, I don't know, here. Okay, so I do explicitly transfer everything to be floats. Action buffer. Oh, and this gets .2. Why did I do this? I think these are unsafe copies, though. These are actually unsafe copies. Actions, copy. This is float 32. Alright, let's see if this fixes it. That would be kind of funny. So I don't know if these copies are actually checking the types match. I think that it's possible that this is what was messed up. This code's a little bit of a mess, because this is like, you don't have Python's indexing syntax. And all it's doing is copying a bunch of observations into buffers. Still broken, it seems. Yeah, this is not training cleanly. What's this say? Rewards? Clamp. Oh, hang on. Try this. This very well could be it. If we're not clamping rewards correctly. That absolutely can mess up training. Thank you, Yassine. Still seems broken. Damn. Well, we have a bunch of checking to do. I want this to not take all day, so I'm going to put a time limit on this. If I don't solve this by 3, so 52 minutes, we'll just go to TinyGrad. Let me use the restroom. I'll be right back. I gotta grab myself more coffee. And then we'll keep cranking on this. Oh, we'll keep cranking. I get so lazy around the holidays. I have like an instinctive need at the moment to be drinking hot chocolate and like playing games and not doing any work. But then Puffer does not get built. So instead, today we will attempt to get this thing to work. The perf test is at 30 mil. If we can actually get that 30 mil, then we've pretty much eliminated all the overhead problems we've ever had in games. I no longer allow myself to play the games that I would like to be playing because that is straight heroin. I've got a stupid number of hours in 2 different MMOs. What I've been doing lately, though, is this, Aaron Shore. This thing is awesome. This is a single dev built like a full single-player MMO with scripted bots that follow you around and fill out your party. So I've been having fun with that, and I've also been getting ideas for Neural MMO 4, because once Neural MMO 3 is solved, there will be a Neural MMO 4. You'd like Factorio, but don't because I like Puffer. Actually, very wrong. I generally do not like that type of game, Tim. If I will optimize the crap out of like gear setups and stuff in MMOs, but the factory style optimization has not been my thing. I played Satisfactory for a couple weeks and got bored. Yeah. I've seen RuneScape has gotten a ton of cool updates in the last couple of years since I have not played, and as tempted as I am, I know I cannot download that game. Straight heroin. Actually, both of my favorite games have gotten like massive updates. They're both like 20-year-old games, and they've both gotten massive updates that I know I would enjoy, but I would not be able to stop playing for a minimum of 2 months straight. Like, I am absolutely capable of playing something for 12 hours a day for 2 months straight. It's just like complete reward hacking. Yeah. Dark Age of Camelot. Oh, that's a throwback. One is Guild Wars 2? Nope. Old school RuneScape is one of them. That one's pretty common. And the other one you only have heard of if you're in Europe, which was Dofus, which I found on Miniclip, not being from Europe. And those two are probably my favorite 2 games of all time. But they are straight heroin. French, yep. It's tactical fantasy chess on steroids. If it's any context for the amount of time on those games, I have an Infernal Cape and a Dusted Omelet on RS. And I think I've had parties of up to like 6 200s that I would play jointly on Dofus. Yeah, it's a little bit of time. A little bit of time. Ultima. Did I miss that? Honestly, like, RuneScape back in the day was not even that good of a game. I didn't play that when I was growing up. It's actually gotten to be a good game in the past few years. Because they basically just kept doing the old school style of content, but then they added actual mechanically interesting stuff into it. So it's like they had a okay game, and then they broke it with RS3, and then they made the old school version, and then they added more stuff to that, and now it's good. Hey, Ratswag. Albion? That's the PvP one, right? I've only heard of that one because of the PvP. Yeah, I really like MMOs. Part of it is just, like, the games are awesome, but it's also, like, the idea of a simulated world is just so cool and interesting to me, that, like, progresses over time as the player base does, and it also happens to be a stupidly good model for AI, so I kind of got everything in one bucket at the same time like that. And pretty much all of the low-level stuff as well from Neural MMO, it just came straight from the exact implementation of, like, the RuneScape tick system and stuff. Type. Date batch. Like, batch. Like, no data. What? That doesn't sound good. Oh, you dummy. Batch. State. Shapes. The heck did I do? What the heck? First, just like items. Nope, not one item. Flatten 0. State flatten. Just here. I just want to make sure we're updating the right thing. I don't never use LLMs for anything. I use them as fuzzy docs. I just don't like them writing my code. Generally, the only time when I reach for LLMs to write code, it's because like there isn't a way to even learn how to do the thing that I want to do. And that's usually a factor of like having to work around of big clunky systems that I don't even want to have there in the first place. Like the Torch C++ API is actually a good example of this because it's just not documented well at all. And then trying to get that to play nice with CUDA is like, ah. How did this frickin' go? Oh wait, no, it's fine. Okay, so this actually... no, I needed to do this. I want to make sure that this is getting copied correctly, you see? Yeah, this is the thing that could be wrong. I don't know if silently one of these is making a copy. That's like the main concern. Okay, so state before is 0. Okay, this is correct. So apparently narrow never copies, which it shouldn't. So why, like, what the heck else is broken then? I'm gonna set this num buffers to 1 here real quick. We're gonna try with 1 buffer, and we're gonna see if it still breaks. Where do you get this 80x faster than Boy from, though, is the question. Yeah, no, you did. This is why you got me so excited. You did the profiling wrong, man. It's 4K frames, like, rendered. They have it right here in the docs. The 395 times real time times 60K frames. This gets you pretty close to that 24,000 single thread. Because, like, if you actually get 80x the performance of Boy, like, you will fundamentally change the whole field of RL. I'd be so surprised if you can get that, but... Ooh. Okay, look at this. So now we have 300 something score. But now if I change this to 2 buffers, it breaks? Really? Oh, I wonder if we do actually have genuine race conditions in here. That'd be kind of embarrassing, right? There's no way to, like, compile the code of an arbitrary Game Boy game to run natively on a modern CPU, right? There's, like, no reasonable way to do that. So you can run it not with an emulator. Because, like, obviously if you re-implemented Pokemon for a modern CPU, it could be way faster. There is. So, like, not even having the emulator, just, like, poker to full disassembly. Yeah, but it's disassemble for the like the hardware of, like, the original Game Boy hardware, right? Like, you see what I mean, right? If it weren't going through the emulator before HLE, that should be way faster. If you had a way to just do that for any Game Boy game, that would be, I think then you can genuinely get millions. I will be shocked if you get an emulator to millions. If you do it, and then it just rocks. And I will be very, very happy to be wrong on that one. Interesting. Either I have messed something up here, or I have genuine race bullshit happening. Wait, I can't have race bullshit happening. This is single-threaded. Okay. Peanut GB. They don't have perf bench. FBR, you'd have to benchmark it. They don't actually have a benchmark that I can see here. They just do like, oh, it's very fast, but like... Watch the training. Yes, Tim, that's what we're trying to figure out. Exactly what is going on with the training. Buff times block size, buff times block size. Oops. Block size, patch. And how the heck? Why are these results not the same? These are synchronous. Huh? You do vec receive. This is a blocking copy, right? Am I dumb? Like... Yes, it blocks, right? That's the whole point. Who does stream synchronize? Vec streams of buffer. And then we mem copy back. I guess I can do it this way, right? Right? The heck? So it works with... buffer, but not two. That's very irritating. Heck. It is a pure empirical science. You're treating it as not one, and you're doing it wrong as a result. They should literally be the same operations, right? Oh, I forgot there is an RMS norm. No way, though, right? Is there any genuine way that it's like it could just be the RMS norm? I don't believe it, right? Otherwise, the ops are the same except for that norm. Why RMS norm is evil. Replace that crap. I wonder if you can just replace replace it with like a running norm of some type. Something else, ideally. Or what are the possible... Can't think of any other possible explanations. Vec size over vec buffers. This is correct. Hypers wouldn't be different? I don't think so, Tim. Like, technically, their RMS norm gets computed... No, wait, RMS norm is not over batch. So it is identical. Yeah, it should literally be identical. Right, RMS norm is over just the hidden dim, so it's... Yeah, it should literally be identical. Yeah, I was thinking of batch norm, so no, that can't even be the issue. Get num buffers times horizon. H, and you get I divided by num buffers. And then we narrow like this. Logit's value state out. This gets copied. We double check that this propagates to state. Obs gets copied back. Obs comes from here. You know what happens? I wonder if we internally have race hang on. Python backend solves? What do you mean? No. We have a whole bunch of different things at this point. I'm gonna try changing these to false. I have an idea. I bet you that we're not getting, I bet you we're skipping Torch's CUDA sync mechanism and we're missing a sync. Whole MDP discussion is just so stupid. You're way better off thinking about RL like in terms of games than you are thinking about it in terms of MDPs. Is this still not gonna solve? Really? Could have sworn it would have been this. Those are equivalent? No, they're not. That's not remotely true. No, it is not. You'd have to cheat the time axis into the MDP, and then that defeats the point of an MDP. And even if you do that, then you make the MDP way, way more general than you need, and the model becomes too general to be useful. I didn't say Markov games, I said games. If you just sit and think about the structure, if you think about the definition of an MDP, and then you think about the structure of a problem that you would expect given an MDP, and then you look at the structure of an actual game, you will see that those two have you thinking about very, very different things. It's like simultaneously over and under specified, funny enough. It's like too general in ways that don't matter, and then it's missing shit that does matter. Not to mention, the MDP on its own is useless, and you at least have to go to a POMDP where you can't even prove anything anymore anyways. I'm so surprised that that doesn't work. I thought that would be it, man. You receive this buffer. Copy underscore state out. What on earth? This is not doing any threading. Oh, you know, I do wonder, actually. Hang on. No, the threads don't even start. Problem formulation? Yes, but it's not a useful problem formulation. It doesn't actually give you a good model of the problems. So if you're thinking about the problems that you're looking at in terms of MDPs, you have a bad formulation. Yes, you can prove things, but the formulation of an MDP mismatches the formulation of the problems you actually care about so badly that it doesn't actually help you to do that. That's the point. That's the thing. There isn't a useful formalism you can write down. But it's not just because you don't just because the only formalism that you have is not particularly useful. How do I say this? If you have a formalism that doesn't match the problems you care about, but it's the only thing you have, depending on the mismatch, right? You can either stick with the thing that is not a good representation, but is what you have, or you can abandon it and do your work a different way. So I found it way more useful to just abandon the bad formalism. You treat RL as more of an empirical science. It's guided by intuition and then extensively experimentally verified. Which is kind of what's been done with the rest of deep learning, frankly. But for whatever reason, the formalism in RL is every bit as bad, if not worse, than in the rest of deep learning. But academics are very, very attached to it, and it's shit. It's useless. And they've held the field back as a result. Every bloody paper starting with MDP formalism is not... It's not just useless, it's actually actively harmful to how you think about problems. What even is an RL problem? Interaction. Learning through interaction. That's the whole definition. A problem where you have to learn through interaction with an environment. See? I can come up with a definition that anybody can understand that captures the actual thing that matters to the field in just a few words. That is so people will argue with me about, oh, but MDPs in the history and the this and that. It doesn't matter. the point of a definition is that it is useful for conveying the thing that you're talking about, right? So the useful definition is through interaction. How can this possibly not work? That is so weird. Wait. Uh-oh. No, wait, is this fine? CUDA mem copy. C reset. Unsigned char. Which is correct. Papers that consider MDPs implicitly, yes. So you're allowed to do work on MDPs, that's fine. But, like, it's not a good model for the class of problems that you think about in RL. Like, framing problems as intuitively as possible as things that you can visually understand is much more useful for understanding what you can and cannot solve than is the very abstracted language of MDPs. There's a reason that we do so many of these problems as games, right? Games are very intuitive. Now, there is one misleading thing, which is that, you know, the agents can't see the graphics on the screen like you can. If you put a key over here and a door over here, that's actually a very hard problem because it doesn't know what a key is. But if you, like, this is a concept that you can explain to somebody in a paragraph or two without any mathematical background. And then once you get that, like, you kind of unlock everything. You see, you can actually understand most of what I think about in RL without any of that mathematical formalism. How mem copy. Yeah, but this buffer never gets. Send over the actions. Mem copy from GPU to CPU. Device to host. Block size, action size is 1. The float. And when I copy this, GPU actions, copied as a float. There's geometry to the problem. How they transform. Satisfactory. And that can be your goal. Your goal can be to come up with satisfactory theory, but all attempts I've seen by people much more mathematically gifted than I am have not only failed, but have not even contributed to the practical advancement of the field at all. Whereas on the other hand, I have a very clear-cut path forward. Like, even though I don't have some sort of grand unifying theory, I have a very clear path forward where I can tell you with confidence that, you know, these problems will be solved now, these problems will be solved in a year, these problems will be solved in 2 years. I count things as important to the extent that they let you solve problems, right? So, like, in my mind, an infrastructure contribution that makes everything run 10 times faster is just as valuable as an algorithmic contribution, right? That improves, like, asymptotic performance on some environments. Well, in other areas, right, the math is actually very important, right? Diffusion, at least, is one notoriously mathy area of ML. But, like, math is a tool. Engineering is a tool. Science is a toolkit. You can't just bash every problem you see with the same tool and expect stuff to happen. The reason I've gone so far down the engineering route is because it was the most useful tool for what I wanted to accomplish. I wouldn't be bashing my head against RL doing all this engineering if it weren't actually working, right? I'd try something else. Yeah, I do have the degrees, and the thing that I like about having the degrees is that if I say this without the degrees, you'll have people who do have them saying, oh, well, you're just a Philistine, you don't, like, have the background to appreciate this stuff. Now I get to say, I do, and you're still wrong. And by the way, here's your RL that actually works and is fast now. Universal computation, targeting all targets with Zig. If you can make stuff fast, awesome. You kernels. I'll be looking at this stuff much more closely if you beat those perf targets. Wait, am I doing this right? dim name index. And this is fine. Oh. Wait. Select 1 and H. I divided by num buffers. Yeah, that's fine. So then you get this one dot narrow 0. March. Zig and Randlib. Yeah, Boone. I mean, we could have done Puffer with Zig, but like, there's really not anything, at least so far. There's nothing really Zig has that I'm missing in C that I would want. C is just such a simple language. It's just very nice. Obviously, the C++ is garbage, but like, that's the reason there's C++ here is because of Torch. And at least for now, there's not really much getting away from Torch. I'm going to spend a few more minutes on this, and then we're going to go to Tinygrad, because I'm kind of stuck for now. I honestly, does anybody, like... I'm not even threading this at this point. I don't see how this can possibly not be working. Why are you trying to replace CUDA itself? Like, why would you do that? CUDA C++? Well, I mean, when I'm writing CUDA kernels, I'm pretty much just writing C. Yes, I don't like the fact that CUDA is technically C++, but I just don't write C++. My solution is coding. I highly doubt it on this, man. One nine two 0. Threads. M's threads. 92 threads. 2 buffers. Right? Create M's. M's. Did not change. Float. Action type is not an int though, is it? Wait. Action type. The float. That shouldn't change. So, I mean, the thing I fundamentally don't understand, you see this is getting like in the 20s. Okay, so if I just do, I'm going to say we're going to create this end with 1 buffer instead of 2. And then I'm going to say that we're going to do 1 buffer here instead of 2. Discovery via simulations thing. Quite confident, because simulation is already used in several areas of science, right? Very heavily. Simulation is already the tool that people rely on, and this makes simulation a much more powerful tool. Because instead of using it to see what happens, right? Like simulation lets you ask the question, what happens if I set up these conditions and run, right? So RL lets you say, how do I get to this point in the simulation? Save states for PokeRL? Yes, Autark. And actually, the Puffer 5 plans have to do with save states in general. To get Puffer 4 done first. Okay, you guys see this? Look, it immediately starts learning, right? And yeah, there's some janky stuff going on overall, but at least this immediately starts learning. Feeders. Yeah, you'd think so, but actually I think that the major breakthrough, the next major breakthrough of AI is going to revolve around save states. I sort of flipped my opinion on that. It'll get explained with Puffer 5. That's like another probably 8 months away though. It's going to be more than efficiency, man. It's going to be an asymptotic improvement. And this is telling us that literally the exact same ops, the only thing that possibly changes is these indexing ops and the vec backend, right? Then the vec backend, we have reset that just resets everything. These transfers are all synchronous. Size of float, rewards, terminals. I see nothing that can possibly be wrong here. Concept. Physics already heavily uses simulation and research. It works on one buffer. It breaks on two buffers. These ops are synchronous. These are your clues. Receive does nothing, because send is already synchronous. Observation batch. I is 0, right? I just do not see anything that could possibly be different. It can't be any of the D types. I just changed literally all of the operations to be blocking. The I only think that torch is like so screwy. I gotta get off of this and do tiny grad. It's like this is gonna drive me nuts. I'm gonna know that I'm gonna have to do this on Sunday, which sucks, or on Monday. This is one buffer. 2 buffers versus 1 work when passing to model. The model goes through half the data, computes actions, actions get transferred, those items get stepped, it grabs obs from the second batch, and just interleaves them. I'm doing everything synchronous right now to debug, and it's still not working. I figured it would be. Let me just make sure. I just want to make absolutely sure it's not some bullshit async thing. Oh, subs. Top and meanest reviewer. Huh. So being mean as a reviewer is not bad. Gatekeeping useful work for bullshit reasons is bad. Yeah, so even with 2 device synchronizers here, this is still fucked. What mean meant here, though? Look, as a reviewer, you can write, hey, this paper is garbage. Like, what the fuck are you doing? And, like, that will not earn you my condemnation. The only thing that earns you my condemnation is being an imbecile. You know? People have, like, the wrong idea as to the point of review and publishing. Like, the most important things are, like, is this technically correct? And is this framing of this misleading? If both of those are correct, then, like, publish whatever. Like, honestly, you can already chuck most of the papers if you just, like, if they say, oh, but, you know, you need to be harsh because, like, we have too many papers. Well, if you just throw out the papers that are actually wrong or misleading, you have plenty of room to accept papers. Framing is always misleading? Exactly. Because the review system doesn't punish you for framing your paper in a way that's completely misleading. In fact, it incentivizes you to do so. Go look at Dreamer, the worst offender. Voyager's another one. Have to get rid of your April Fool's paper. Look, That's an exception. You're allowed to submit April Fool's papers. Wait, did I even do anything? Did I even do anything misleading on my April Fool's paper? Dude, that paper was actually correct. What works? You got it fast? I'd be surprised but not astounded if GPU GBA emulator works. 256-way branching. That's still a lot. That's per instruction. Is it fast? Well, you said it was 80x faster than PyBoy before. And it was about the same speed, so is it... It doesn't even have to be 80x faster, man. You make it 10x faster than PyBoy, it'll be a big deal. Well, frame skip obviously is going to make it slower, because, like... You have to actually compute those... Well, you don't have to compute the states into obs, I guess. So there is some stuff you can prune, probably. Set up a harness. There. This is just... I know I said I was going to do tiny grad, and I need to. This is just driving me nuts, though, because I cannot figure out why this is happening. Like, how is this happening like this, right? Oh, wait. We will do tiny grad. I'll stop at 30. Give me 8 minutes. I'll test a couple last things. Just... $8K. 8. Is that on one thread? Or is that with all the threads? Yeah, this is correct block size, damn it. If that's with all the threads, that's about PyBoy speed. This is the weirdest thing to me. I'm trying to think, like, where even, like, sources of error could be that I haven't considered. Rendering all 4 with the Raylib? Oh. You probably shouldn't be doing that. Reading the right M's in the Pufferlib bit. I mean, I can't see where it wouldn't be, man. If I set it with one buffer, it works. With two buffers, it doesn't. I just do buffer is going to be I% 2. And then I over 2. So this is the time. And then this is the buffer. Everything is indexed the same. State batch gets this copy. Right? Everything gets copied into obs buffer. Act buffer, log prob buffer. $15K with no rendering. Which is what I said, right? Like with the current speed, 16K cap. It's cool for sure. Hey, don't get me wrong, it's definitely cool. But you did kind of start this thing with saying that you'd gotten it to be like 80x faster. So you got me all excited about what would literally be a generational leap that would let us do a ton of new RL research. Now let's see you get your 10x would be good. 10x I think would be good enough. We'd be able to use these envs for like we wouldn't be able to use them in like our standard research, but we'd be able to use them as like hard evals. 80x we would be able to use them in pretty much standard everything. Yeah, 80x we would definitely be able to use them. I don't think there's that much perf in the chip to squeeze out though, without going to native. All right, what's your favorite LLM, Tim? We'll do the meme, just in case the meme works. Codex. Can I get that online? OpenAI. I don't want this thing in my freaking code base. They have hang on. Oh, this is Sonnet. Okay, so I don't have this on here. Let me at least see. We'll do the meme. Separate state tensors. This thing's entirely wrong, right? I'm pretty sure this thing is entirely wrong. Initial state. Some layers, batch size, hidden size, right? Layers, batch size, hidden size. Narrow. Yeah, no, this thing is completely wrong. I actually didn't even expect it to be that wrong. Let me make sure I'm not just missing something, but no. Because we're taking every other step, right? So this is going to update the first half of the state. And we check that this propagates correctly. Completely wrong. Here, I'm going to commit this. If anybody wants to figure this out, feel free, but I'm going to do tiny grad stuff. That's kind of disappointing I couldn't figure this out. Like, we got the perf. We got the perf to be good, but I couldn't figure out this one bug. That's really obnoxious. Thread pool. I don't know if I would do your own thread pool. I guess you can do that for now, man, but like, unless you're implementing this exact architecture, it's gonna end up being slower. I just bind it to Puffer's Vec for now. Like, this thing is gonna end up being way faster than whatever thread pool. Than a thread pool. Not at those speeds, it's not. You need buffering. The Vec architecture is the thing that probably I've spent more time on than anybody in the world for RL. Like, let me think. Probably like the Vec architecture and then like the env optimization stuff. These are probably the areas I've spent more time on than anybody. Obviously, the threading stuff I'm doing today is looking completely fucking stupid because I haven't had to even do threading. I did it with multiprocessing. But even then, like, the multiprocessing in Puffer is very low overhead. Like, the main perf is not even going to be from going from multiprocessing to threading or Python to C here. The main improvement that we're going to get is going to be from buffering the GPU transfers. Gotta love when the people that are haters are just fucking idiots. It's one of my favorite things. It's actually, I think I'm way more happier when, I'm way happier when I have, like, critics that are utterly stupid than when I have no critics. Because when you have no critics, it's like, okay, echo chamber. When you have critics, but they're obviously idiots, way better. 83k? With Raylib? 83k good. 83k would actually be very good. Okay. I will have to see what you're doing. I'm gonna let you keep cooking on this for a bit. Let me use a restroom real quick. I pushed this stuff, so if anybody wants to help me figure out what I've screwed up with double buffering, code is there. Build vec, and then setup.py, build x, build torch, in place force. And there are just two places where I have it hard coded to one buffer or two on create environments. But I can't figure out why it only works with one buffer. Fully synchronous, no threading. It's very odd. Check Discord. If you got 83k rendered on the same machine, 83k, where's SPS? Oh, 75. You do still have to add frame skip though. So Autark, the exact setup, it's you render every 24th frame at the moment. And if it's not clear why you do that, it's because Pokemon does not have control that matters on the order of every frame. Like, so if you just take actions every 24 frames, that's how long it takes you to walk a tile. So like, there's no point of processing data any faster than that. You're just throwing away compute. This is with frame skip. So this is rendering every 24th frame. What did you do that got it from like 15k to 80k then? You don't have that many threads on here. Like, you don't have that many cores. You made some architectural change? Parallel? I thought you didn't have it running. You didn't say that you had it rendering it, like... But you didn't say that you had it rendering that fast before. You had it at 24k... You had it at 24k without rendering, right? 24k per core. Which with frame skip is 1k. So how on earth did it get from, like... That's more than a multiple of 32. So I don't understand how that works. And you also set more workers than you have cores. You have 64 workers on... Is this a different CPU? No, this is the same. Okay. One to set. Yeah, but you shouldn't be a single core. Yes, but 1 times... You had 1,000 times... I thought it was... You had 20-something K with no rendering, didn't you? Which is, with frame skip, should be 1,000 per core. So how on earth did you get better than linear speedup? Like, 3x better than linear speedup? Especially since if this is the same CPU as before, that CPU architecture only has 8 good cores in it. It has 8 P cores and 16 E cores. We have those exact machines back here, and that architecture is kind of a pain in the ass. Like, you never get more than a 16x out of it. Skipping is faster, not slower. Oh, wait, are you counting... Wait, you have to still step the state, though. You can't skip the state updates. So you get 24x less data. We're rendering all 60 FPS. I'm so confused. Do you have your FPS number wrong? Like, the way that you should be calculating the FPS, it's by the number of rendered frames, but you're only rendering every 24th frame. So is this multiplied by 24? Are you counting the number of states here, or are you counting the number of rendered frames? Because if you're counting the number of states, then this is like half or a third of the speed as Boy. We don't step the PPU at all. Frame skip, we don't step. All right, so, but like SPS, so when you count SPS and RL, okay, I guess it depends because people do it both ways, to be fair, but the comparison to PokeRL was the number of rendered frames, and you only render every 24th frame. For frame skip, we don't step the PPU at all. Yeah. The 24 frame skip. But like, you're counting SPS with 24. Okay, so then the number of rendered frames is this divided by 24. Right? So this is the number of game ticks total that you're rendering, basically. But then the number of rendered frames is 1/24th of this, isn't it? If that's how you've reported it, then this is between half and a third of the speed of Boy. Because there's a metrics reporting difference. You're quantifying something in a way that is different from the way that we were quantifying. No, we don't want you to render all 24, Artark. That's not the point. The point is that this SPS metric gets divided by 24. So we're counting the number, so we are counting the number of examples that are actually used during training. You're only using the frames during training, right? You're not using the things that are skipped. You're skipping because there's no reason to train at that fine grain of a time resolution when Pokemon doesn't have control actions at that low of a resolution, or at that fine of a granularity, rather. So the number of frames that you would train on would be this divided by 24. Frames aren't steps. You can define it either way, but at the end of the day, the thing that really matters is like the amount of real-time game data that you're training on. So if you want another way to look at it, it's speed up over real time would be one. You can define it either way, but like the point is you're defining it inconsistently with how we had it defined, and then like I think you're comparing your 24x higher metric to the one that we have, which is dividing. You know, if I were to convert to your metric, it would be, let me think. I think we got up to like 8,000 steps per second-ish training, if I recall. So yeah, 192K with your number there. I will check this after, Tim. Previous screenshot, that was without frame skipping and without parallelization. What? I'm not cheating you on metrics here. I'm just trying to make sure the Oh, okay. So he just loaded the website, saw the random demo, and thought I was a moron. Fair play. You care about... I don't care about pixels, autark. Here, let me explain to you the thing that I care about, and let me explain to you why it is the correct thing to care about, okay? I don't care whether you train on pixels or not. That doesn't matter. But however you do it, the agent doesn't need to take a step every time the game ticks. And the reason for that, right, is that if the game is made to run like 60 frames per second, the control of Pokemon is not that precise. You would use that level of control for like a fast flying drone or something. Like Pokemon really only needs a couple of button inputs per second maximum. And it just so happens that if you run one tile takes 24 frames to run. So a skip of 24 steps gets you control at the precision of one tile. So whether or not you render, it doesn't really make sense to take actions more frequently than every 24 frames. Yes, you have to step every tick, but you're only going to use 1/24th of those steps for training data. So you can calculate the metric either way, and it's done either way. But as for the practical of training, if you're going to compare apples to apples on speed, it's like the amount, it's basically how fast you can run the environment versus real time, if you think about it, right? So like here, with PyBoy, it says on an 8-core machine, you could potentially do 3,000 hours of gameplay in 1 hour, which sounds like a lot of data until you see that on Neural MMO 3, like we do, in a few days, we do 12,000 years worth of gameplay. So like compared to the other environments we have, the delta in real-time equivalent speed is still 2 orders of magnitude off. And if you were to bring it up to 1 order of magnitude off, then we could basically start using it for more complex tests and stuff. I'm implementing as a frame skip at the emulator if it would be, so it would be 24 times faster if I did that. Frame skip at the emulator. You still have to do the operations, right? Like the game still has to advance its state. Because like once you press the button once to walk, the emulator, it still has to update 24 times. Now, I don't know if PyBoy like spends a bunch of time computing observation data or something, and there's something that you can prune. But like, that's what you'd like to get. Does that make sense though? Like, I'm not trying to cheat you on metrics here or anything. It's just straight up like, you need to run a lot of hours, a lot of days, a lot of years worth of games. And you can define the metric either way. But like right now, there's still this gap. Don't update CPU except every 24th. Yeah, so that's fine. I mean, you can easily compute this number, right? Which is the real time. You can easily compute that as well. That one would give you a comparison. So frame skip is a little bit of overhead. You can see here 344x real time with frame skip 15. Because rendering is really expensive, but if you're only doing it every 15th step, it's not a huge perf penalty. So when you're doing frame skip 24, like the idea is it shouldn't be that big of a penalty over the sim, and you're mostly constrained by how fast the emulator is running here, right? Okay, let me use the restroom and then we're gonna do some tiny grad. I think I've made it clear. Hopefully. Alright. Tiny bread time. Enough fiddling with this stuff. If I feel like it, I might later tonight, I might come back to the other thing. Jess, Tim, if either of you wants to fix it, by all means. But I gotta start on some tiny grad stuff. Tiny grad useful? That's what we're gonna figure out right now. Or we're gonna start on. I enjoyed what I saw of it so far. Oops. Which machine did I do this on? That's tiny grad, yeah, it's right there. Right, I think I was doing Torch Mingru and Tiny Grad Mingru, right? Okay, this is not running the full network yet, is it? Oh, I'd forgotten that I'd actually had this get to this point. Cool. So, yeah, here's the Mingru layer. Train step. This is with beam. Okay, so without beam, super slow, right? Now the question is, why is this slower than PyTorch? And actually, what are we competing against here? Is this with compiler or is this eager mode? This is literally Torch eager mode, right? Interesting. Let's see what other stuff they got. Enable CPU backend. It's on GPU by default, right? Hang on. Yeah. So it is actually, it's on GPU by default. It's actually kind of funny that they do that. I think it's kind of a good thing. Claude, you stupid, go away. Runtime. Op. Efficient data tensor storage, okay. What would be the possible benefits? Allow me to show you. Where is it? So I posted. Did he reply on this one? No. Is it? So there's one of these posts that Hots replied to. Is it this one? Damn it. Here. So I made this post about having to fuse a bunch of models. He said, hey, have you tried TinyGrad? It's very optimized for small models. So I said, I haven't because of this. And he says, I'm fusing tons of small kernels. TinyGrad will literally do that for you. I said, okay, I'll be surprised if this gets close to perf. If I spend a little time to benchmark and post publicly, will you take a quick look and tell me if I'm doing the TinyGrad one stupidly? So he says, sure. Written correctly and with Beam, TinyGrad should outperform all but the best handwritten kernels. So basically, he says, hey, I think that this will be fast for small models. And he's offered to check once I run some perf tests. So worst case scenario, you know, I say, hey, I tried this, take a look. And he says, yeah, this perf test is right. I guess it doesn't work because this, and that. No harm done. Then I just know even more so that I'm building Puffer the correct way and there are no viable alternatives, right? Best case, we find something useful perf-wise where we can, like, use some of their kernels or something, right? So pretty much that. Oh yeah, where's the profiling stuff? I had a whole bunch of TinyGrad people. Actually, let me just tweet this. Cool. Yeah. That's the idea behind this. Where is their profiling stuff? Some people told me they have one kernel on the GPU. Large compute graphs into subgraphs that can fit in a kernel. dot pi. Oops, this is TinyGrad's neural net file. Is not that long. 350 lines. They actually do not have that many ops, and they just so happen to have most of the ops that I would like. It's very succinct, I'll give them that. The question is if it's fast. Their back end. Correctly written and with Beam should outperform all but the best handwritten kernels. Okay. So where do they have their TinyGrad profile? I was told there's like a little web thing or whatever. Biz equals 1. SQTT profiling. Is this it? Wait, normal profiling. Developer docs. Bunch of tutorials. Wait, developer docs. Okay. Array tensor cores. Cool. Okay, where's the profiling thing? Intro. We can easily pry under the hood to see how this computation occurred. Okay, so you literally just run debug equals 2. Cool. Debug equals 2. Yeah, that's too much profiling, my guy. Let's see what this gave us. Oh, okay. Because this gives us... Hang on, so we want to do... exit. How does that still give us a billion things? Breakpoint. Because I'm not running the right thing, apparently. That's Torchman grew, dummy. Okay, so... Okay, cool. So... this has given us... all sorts of data. 4 main rows in the output. The first 2 empty refers to the variable A and B. Element-wise is E. Debug equals 4 gets you... oh, gets you the GPU code. Whoa, that's actually really cool. So I can just get that and paste it, basically. Okay. It would be nice if this got us readable code. But let me see what we're getting here. Because this is actually very cool. Copy. NV Python. But then this is not going to give us... How do you profile, like, the optimized version? Oh, yay, now we have tinygrad people here. Oh, running with viz equals run should open in a web browser. With debug as well? Okay. So we have a ton of ops here. We have, yeah, a ton of operations. Yo, Ozzy, so I just profiled one operation. If I want to get a profile, like, you know, in Torch, I would run profile, and I would average over a ton of, I'd average over several iterations, and it would accumulate results across runs of the same kernel. Is there a way to do that here? Because I want to basically see where, like, how efficient tinygrad is compared to Torch, and compare stuff like, you know, copy times, launch times, actual kernel time, stuff like that. Also, why is this not, like, part of the docs? Or is it? Is it literally just in the flags? Yeah, it just links you to the viz. Very top, there is a profile. Here? Ooh. Okay, so what should I do then? Yay, we have summoned the tinygrad users. So how should I do this? So I just did like one-step profile here. There's a warm-up here, and then I do the main thing like this. So how should I do this so I can get an aggregated profile? Because, like, if I just do this, right? So this is now going to spam a ton of stuff. Oh, does it aggregate it for you by default? Am I just dumb? Okay, it seems like it does aggregate it, but I don't think it excludes the warm-up, does it? Okay, schedule 17 kernels. So we got this funky graph, which is presumably somehow my network. View kernel graph. Why you do ML and AI and C and not on Python? I have both. You can't write the M's in Python. If you're doing reinforcement learning M's in Python, you're doing it slow. Like, slow by a factor of 100 or 1,000. Like kernel map. All right, how am I supposed to use this thing? Like, these are the kernels, I presume, right? There's your CUDA. Global. Thing. So how do I'm just trying to figure out like how am I supposed to use this data? I don't get like it doesn't show me how much time is being spent in each kernel, right? Okay, view input graph. Number the uops. Earliest rewrites. Where do you learn to do the C part? I just started doing it. It turns out it's just low-level dev is much easier and more fun than you would expect. I'm honestly, at this point, I'm way happier when I get to write C than writing Python. C is just so simple and easy. Run Rangeify. Reduced collapse. I don't know what this is. First, view tagged Rangeify. Split kernels. Kernel graph. I think that this is because I don't know why there are this many of them though. I mean, we do have like a 4-layer stacked mingru, so presumably this is that pattern. You have a starting point? Yes. I have I've got educational material on my X. Right here. These 2 articles have all of my best advice on general programming in ML as well as on how to get into RL. Holy. 1, 2. Like, what am I supposed to do with this? This is a very pretty graph. But, like, and this is, like, very nice and smooth as well. So, good job on that. But what am I supposed to do with this? Final trim step in the profiler. It should give you timings of each kernel. Okay, so I see. So you can do like this, right? I don't know why I didn't try that. So is it this thing? Batched 14. How did the program is split into kernels and how they're then optimized. Right, but like the main thing that I would want is timings. right? Like, I would like to know how much time is being spent in copies, how much time is being spent in, you know. So this has just dumped a ton of data here, right? But then it's not aggregated over batches for me. So this is batch 14. 4, 5. So I think this gives me, this does give me the kernel breakdowns, kind of. Of course, they're not like named in any way that I can make use of. I see there are some smaller ones in there as well. How do you make use of ChatGPT? I generally do not like using LLMs to write large chunks of code, with some small exceptions. The main things I use is I have SuperMaven, which is just like a one-line, really stupid fast model for autocomplete. I basically use it as a better LSP. And then I will also use whatever latest model I feel like as fuzzy documentation. And I always get a model that's like fast and responsive. I'm never going to be sitting there waiting 2 minutes for a freaking model. Maybe if you beam and just do one step. Okay, I can do that. Because it should be cached anyways, right? But I thought it needs... Does it not need... it should need a warm-up even with beam, right? Don't you have to warm up the kernel? I don't think one step is going to give us a good profile. Like, this is kind of a dumb way to... Like, this is kind of a dumb way to profile stuff, right? Like, okay, this gives us something simple. But... like, this is not aggregated in a useful way. Compiler, R... Yeah, I still don't know what this is, man. Yeah, you can't just zoom in on one. Like, that's not how you should be doing stuff, right? You need this to be... Oh, George. Aggregation is implemented? Well, they have to be doing something, because they're profiling their code somehow, right? Like, they have all this stuff on perf. Unless they're doing everything super manually. What are these giant gaps between these calls? Linear Gelu? This looks like a network. What are these gigantic gaps between calls? Let's see what this profile gives us. Batched 14. JIT capturing. Scheduled 28 kernels, scheduled 14 kernels. Okay, JIT captured 14 kernels with 1 inputs. JIT graph batching 14 kernels. On device. Okay, so what are these numbers? I think this is what the profile thing should tell us, right? Where was it? I lost where I was in the docs. Okay, so it was on the dock somewhere. Ah, your page is white and that hurts my eyes. Okay, so 4 main columns. Design, designate the computation. There is no header on this table. So what is this? What are these numbers? This doesn't have a header on the table. Okay, so they don't even have a freaking map mole. This is not what we need. I think this would be valuable feedback for Geo. I'm streaming all of it. I'll at him with some of it. But I'd like to put in at least some amount of effort before I start bugging him on this. Like, does anybody understand? So first of all, what are these, first of all? What is this number and what is this number? Like, is this like launch and... Like, the table doesn't have a freaking header on it, man. The table should have a header on it. Actually, I'm going to start a little doc. RL to model human reasoning. I don't know. There's some stuff you can do, but it's definitely not guaranteed to match one-to-one in the slightest. Welcome everyone on YouTube. I'm currently trying to figure out, we were doing some optimization on the new vector backend earlier today, and now I am back to evaluating tinygrad. Oh wait, does it say here? "25 microseconds, and the total elapsed time is now at 0.03. Okay, so this one here, this is the total time in the program so far. And this is how long the op took. Okay. So we have, aside from I don't know what happened right here, yeah, we're occasionally getting these spikes where it takes forever. But then most of the time we have 200 micros. Right? And then this goes up to 1,000, is it? Hang on, let's do some stuff. Iters. Iters is 1024, so it's doing 1,000 iterations. And it is saying that this are 200 microseconds is actually tiny. Wait, that's really good, isn't it? Hang on. Num layers. Iters batch is 4096, right? So what is the SPS of that? So wait, 4096 times, or divided by 2. If I say 200 microseconds, that is 0.2 milliseconds, right? I believe so. So that would be 1 ms, so 02, is that it? 1e6. Yeah, which gives us our 20 million steps. That gets us like 20 million steps per second. Which is actually what we would expect, right? Because this is what would match torch. So it's actually almost torch speed, except that randomly we have some of these are slow. So actually, this matches torch, except that randomly some of these are slow. So let's see if I've done something stupid. Oh, you know what I've done stupid? I know exactly what I've done stupid. I forgot the no grad. Try this again. That's still there. But is that way better? That seems way better. Still the same speed, though. Yeah, so that's annoying. So even without this training on, right? We're still at 16.82 mil, which is underperforming. PyTorch Mingru gets 20 mil plus. All kernels and GPU, yep. TinyGrad does that by default. So yeah, like some of these are just randomly slow. I guess we don't see it for Torch. So it could be, because Torch profiles in a very different way. Oh, I like how it gives us G-flops. This is really nice. So this is 13 T-flops. That's a very, very nice addition. What is this mem? arg1 mem, okay. em. Yes. Oh, and then this is the SPS with the profile on goes down to 13, which is not terrible. Okay. What if I said debug equals 1? Now that doesn't get me the same info. Graph rewrite. Okay, so here are ops. Yeah, that's a lot of time between ops. And then micros. Are these actually very consistent? Let's see. Oh, these are very consistent, aren't they? Yeah, look. The actual ops are super consistent. And then there's just randomly these big gaps. Yeah, so Tiny just randomly does this. Yeah, that looks like a decent chunk of perf. You're missing. Why does it do this? Graph rewrite, but these are all over the place, and these are tiny. Batched. You see anything else? Not really. Fuck is dish? What is this column as well? What is... Last row is to list. This will give us the output. Yeah, I already have that, dude. Wait, LLVM. I have context. This, right? Should it be context? Should it be that? Did you get that from an LLM? Cannot import. All right, my dude. It's not that I'm too stupid to like paste shit into an LLM. It's that I'm not so stupid as to just paste shit into an LLM. You don't have to like let me Google that for you on me with like broken info. That's so easily checkable as well. Like the thing that I want to do, I want to get like a breakdown of overhead. Oh wait, here. Viz equals 1 will cause tinygraph to save all pattern matching history and start a web server script upon exit. Scheduler pattern on list of kernels. So, okay, you can actually just go look at the kernels and the code. That's very nice, but that's not what I meant by profiling in this case. I would like some aggregate metrics. Okay, this is UOP graphs. Like, this is a very, very useful tool for looking at generated kernels, but operator fusion, JIT explained. Non-GPU. This is terrifying. I guess you can always just try with and without JIT, but that's terrifying. Batch graph mode or simple batch graph mode. Batches multiple kernels. Thing. Grad holds on to all buffers. Oh, this is fine. Does buffer read? I like that they go straight to the profiling here, but I think they're missing. Yeah, they're missing aggregation over these kernels. I don't know why they wouldn't have that. That's like the first thing I would think to. That's the first thing I would think to do. Would be to do like aggregate profile. 200 micros. So this is 14 kernels. Do this. E is element wise. Split kernels, bufferize to store. Nine uops. Put graph. U. See, can I figure out what this is? This is buffer. Kernel. Shape. Well, I mean, I should do one iteration if I want to do it this way. But if I want to see the profiler, then I can't do that, right? If I just click on one of these, batched 14. So, I mean, I can see all the kernels here. What is this in the middle, right? So first of all, there goes a good chunk of overhead between these two. Okay, let me try something simpler to start with, guys, so I can just get one thing done for sure today. Well, I got 10-15 minutes and then I got dinner, but I think I'm going to do an evening stream tonight. Test tinygrad.py, test tinygrad snorm.py. I think they even have an RMS norm in here, don't they? Hey, Pepe. Let's go check their docs. And they have RMS norm, dim, eps. See if I can do -1. Should I just do .mean? Oh, it's probably the .realize on everything. That's probably doing a CUDA sync. Okay, that's my bad. Oh, that's actually majorly my bad, isn't it? It's gonna cheat if I don't, isn't it? Forward realize. No, I didn't do realize, so we're good. Okay, I thought I'd messed it up. I was gonna be embarrassed, but no. We don't need this count flops. Okay, so this is 73 mil. And then let's do the exact same thing. Oh yeah, and since I'm gonna have to go in a few, for everybody watching, I stream pretty much all my dev, and if you're interested in that, everything's at puffer.ai. You can help me for absolutely free by feeding the Puffer star on GitHub. If you want to get involved with dev, Discord is here, discord.gg/puffer. And you can follow me on X for all sorts of educational and research content, as well as occasional other things, but mostly on topic. Normalize shape. The weird API. It's like this. Come on, Torch. Okay. That is actually good. You see that? So TinyGrad just generated us a 2x faster kernel. Then, pretty sure that's right, isn't it? Do you need to realize on this? Will it cheat if I don't realize? Hang on. Triggers the computation. Create these tensors. I think you do need dot realize, don't you? Any TinyGrad users? Do I need dot realize for fair comparison? Like, or is it gonna skip this entire loop, or am I good? What did the kernels get called? Good point. I'm gonna have to go in a minute or two, but Okay, so it looks like this with this version. If I don't call realize and I do the same thing, then I still see kernels. Without realize, you aren't doing any map moles. So I'm a little confused then, because what's it doing? If it's cheating, it should be way faster. So without realize, I get 102 mil. And with realize, I'm just making sure I don't want it to be doing like an extra CUDA sync, right? 86 mil. There's some variance. Oh, wait, there's a lot of variance. Never mind. Hang on. Maybe it's the same speed. Oh, there's a lot of variance. Never mind. No, wait. It's slower now without realize? Oh, okay. Never mind. We're good. Heh. I guess we need more iters as well. So with realize, we get 108. Without realize, 106. Okay, same thing. Yeah, same thing. Doesn't matter. It's got to be running the computation, man. It's the same speed with or without it. Well, that's actually good, isn't it? Because look. Whoops. I think we can use at least these kernels either way. I'll not app them until I have more comprehensive results. Cool. I gotta run for dinner in a minute here. That is a nice result, though. That is a very nice result. What? Okay, so when I use the full tinygrad, unless I'm doing something massively wrong, the initial conclusion is it's not like magically way faster than Torch. I still see huge amounts of launch overhead, but it seems like we can use this for specific kernels, and this might actually generate us some reasonable stuff. So I think the next step for me is going to be to profile this versus Torch versus my custom kernels for some ops, and we will see what that gets us. I think after dinner, guys, I'll be back on, and I'm going to profile the fuse scan operation versus my implementation, because that's the kernel I spent the most time on. So we'll see if tinygrad beats Torch, and if tinygrad beats my fuse scan implementation. That'll be pretty cool. The beam or something might enforce the realize. Yeah, I don't know why. But regardless, like, this RMS norm op is a pain in the ass. And it looks like, at the very least, right, this is making it like 3 times faster. So that gets me plus 600,000 steps per second to training just with that one kernel. So if I export this kernel to CUDA and I bind this to Torch, like, even without fusing more stuff to it, which I can easily do, that's already useful. The one thing that I think is a little awkward is this is going to export me size-specific kernels. So I don't know what to do about that. I'll have to figure that out. Because, like, I need a kernel that I can run on whatever size input. Hey, Jess. I'm about to go to dinner. I'll be doing a stream later in the evening. We fought vectorization for a long time. It's fast, but there are some bugs with the buffered version. I'm working on that. We started on tinygrad stuff. We got through some profiling. It looks like there's some usable stuff, but not fully done. And I gotta go to dinner now. So thank you, folks. Star the Puffer on GitHub. See you in an hour. Bye.